The night sky had never looked so calm. From Earth, every planet seemed to glide along its ancient path, locked in the same cosmic rhythm humanity had trusted for millennia. Jupiter's bands burned gold, Saturn's rings shimmered, and the stars held their silent vigil. But beneath that calm surface, something was beginning to drift. It started as a faint discrepancy, too small for even the most sensitive telescopes to notice. At the Cerro Las Campanas Observatory, a cluster of scientists were tracking Jupiter's orbital velocity for a routine calibration. When they compared the new readings to NASA's reference models, they found an anomaly, a deviation of 0.00041 seconds in Jupiter's orbital period. A rounding error, they thought. A glitch in the data pipeline. They recalibrated, reran the models, checked the timing software against the hydrogen maser clock. The error persisted. Over the following nights, Saturn began to show the same pattern. A slow drift, measured not in miles, but in milliseconds, yet unmistakably real. The kind of movement that no gravitational interaction could explain. Dr. Lena Kovacs was the first to question it out loud. If gravity hasn't changed, then something else is steering them, she whispered, her voice almost lost in the hum of the control room. The team laughed nervously. Orbital drift wasn't unheard of. Perturbations from moons, solar wind, or hidden mass could cause minute deviations. But Kovacs noticed something strange. The timing of each deviation followed a repeating pattern, a pulse synchronized across planets millions of miles apart. At 03:14 GMT, she annotated the data file with a note. Phase alignment, 0.003 s, identical between Jupiter and Saturn. The next morning, that note was gone. When she logged into the observatory's server, the entire data block for the previous night had been deleted. The backup drive, physically disconnected from the network, was blank. She checked her email. A new message waited at the top of her inbox. No subject line, no sender, just one sentence. Do not chase synchronization. Her hands froze above the keyboard. She reported the incident to the data security office. They promised to investigate, but within hours, the observatory's internal network was taken offline for maintenance. 2 days later, the anomaly was officially reclassified as solar interference noise, and her team's research proposal vanished from the grant system. The story could have ended there. But Kovacs couldn't let it go. She began to dig through archived telemetry from older missions, Voyager, Cassini, Pioneer. Every dataset she opened revealed faint, recurring pulses, subtle, rhythmic fluctuations in orbital velocity, appearing roughly every 73 years. The same cycle, the same alignment, and all of it dismissed as statistical noise. By August 2029, whispers began to circulate through the astronomical community. Private observatories in Chile, Hawaii, and South Africa had independently detected non-Newtonian drift across several planetary orbits. One technician, working for the European Space Agency, leaked a redacted summary to a journalist. Orbital angular momentum variance beyond expected thresholds, possible systemic bias, or external influence. Within 24 hours, that journalist's article was removed from every major news site. Officially, nothing was happening. Unofficially, data scientists were noticing peculiar restrictions. Datasets from NASA's Deep Space Network were suddenly locked behind new access credentials. Cross-checks between ESA and JAXA servers timed out. Requests for orbital telemetry were denied with a new classification code, R47A, temporary access suspension. Something, or someone, had decided that the public didn't need to see how the planets were moving. Late one evening, Kovacs met with an old colleague at a cafe near the Geneva Science Center. He had once managed telemetry analysis for the Cassini mission. His hands shook as he stirred his coffee. "It's not noise," he said quietly. "We saw it during Cassini's final year, a repeating gravitational modulation, subharmonic resonance between the gas giants. We were told to attribute it to solar wind pressure." He glanced toward the window, lowering his voice. "But Lena, the modulation isn't random. It's coordinated, like something is synchronizing them." Kovacs stared at him, her mind racing. Coordinated by what? He only shook his head. Whatever it is, it's outside the heliopause. A week later, she received a secure file transfer from an anonymous address. Inside was a compressed archive labeled Atlas Prelim 3I. It contained raw tracking data for an interstellar object detected months earlier, a cometary body catalogued as 3I Atlas, the third known interstellar visitor after Oumuamua and Borisov. At first glance, the data looked routine: hyperbolic trajectory, high velocity, outbound toward Perseus. But embedded in the Doppler residuals was a pulse, a precise, repeating modulation, identical to the orbital resonance she had been tracking among the planets. Coincidence seemed impossible. If the planets were drifting in sync, and an interstellar object shared the same rhythm, it suggested something larger, something deliberate. That night, she stood outside the observatory dome, the Andes wind cutting through her jacket. Above her, the constellations burned steady and indifferent. She thought about the message: "Do not chase synchronization." Was it a warning or a threat? The Earth's rotation felt heavier somehow, as if the ground itself was caught in that same unseen rhythm. Kovacs knew she should stop. Her funding was gone, her credentials suspended, and her reputation already cracking under the label of anomaly chaser. But she also knew this: every civilization that ever looked up at the night sky assumed the orbits were eternal, immutable, safe. And if that foundation was shifting, even slightly, it meant the laws of the cosmos weren't laws at all. They were instructions. She turned back toward the dome, watching the telescope motor hum as it repositioned. Somewhere in the data, in the millisecond gaps between planetary pulses, was a whisper of a greater design. The universe, it seemed, was no longer a clock. It was a conductor, and every world was beginning to move to a different tempo. If gravity hasn't changed, she thought, then something else is steering the symphony. The comet was first seen by an automated telescope in Hawaii in early 2029. It moved fast, too fast to belong here. The Minor Planet Center listed it as 3I Atlas, the third confirmed interstellar object to pass through our solar system. Astronomers expected another harmless wanderer, like Oumuamua or Borisov. But within weeks, its path began to defy every prediction. When Lena Kovacs received the raw detection file from her anonymous contact, she recognized the signature immediately. The brightness curve showed a repeating flicker, steady as a metronome. Not random rotation, not thermal variation, something rhythmic. She ran the data through a basic frequency analysis. The pulse interval matched the same timing pattern she had seen in Jupiter's and Saturn's orbital deviations: 73.4 years per full modulation cycle. She stared at the graph until sunrise. If the same frequency linked the orbits of giant planets and an interstellar object, it meant they were responding to the same influence. And if that influence reached beyond the sun's gravity, then the solar system was not isolated at all. Lena booked a flight to Tokyo under a different name. The University of Tokyo still hosted one of the few archives not yet merged into the global telemetry network. From there, she could access the original tracking streams from Atlas, the asteroid terrestrial impact last alert system, before they were filtered for public release. The files came on a secured drive handed over by a graduate student who didn't ask questions. Inside were 23 observation sequences covering 6 weeks of tracking. Every sequence contained an identical irregularity, a small change in velocity every 22 hours, perfectly periodic. The change was subtle, barely measurable, but the direction alternated. Accelerate, slow, accelerate, slow. No known natural force could produce that pattern. Lena built a simple orbital model using only the raw vectors. The simulation showed 3I Atlas performing micro-adjustments, as if keeping itself aligned with a moving reference outside the solar system. When she overlaid the trajectories of the planets, those adjustments coincided with moments when Jupiter and Saturn crossed specific angular positions relative to the galactic plane. That was when she stopped thinking of the object as a comet. 3 days later, the same student called her from a public phone. His voice trembled. "Dr. Kovacs, someone accessed the archive after you left. They wiped all logs. They said there was a system upgrade, but—" "Don't say more," Lena interrupted. "Delete my contact information. You were never involved." She hung up, knowing it wouldn't matter. Her hotel room keycard stopped working that night. When she checked out using cash and a false passport, she noticed a man sitting in a parked car outside the lobby, holding a phone to his ear. She didn't go to the airport. She boarded a night bus north, heading for Sapporo, where an old friend was running an independent deep space radio array. Arjun Mehta had once been a simulation engineer for ISRO's Planetary division. He left after a classified project disappeared without explanation. Now he maintained 6 outdated radio dishes on a snowy hillside, listening for deep space transmissions. When Lena arrived, he looked tired but unsurprised. "I knew you'd show up eventually," he said. "You've been poking at something you're not supposed to." She told him about the pulse pattern. He pulled out a drive and opened a log from his receivers. A narrowband signal at 1420 MHz, the hydrogen line, had been repeating for months. Its amplitude matched the 73-year modulation envelope. "You think it's connected?" she asked. "I don't think," Arjun replied. "I know. The signal strength rises every time 3I Atlas passes a certain vector relative to Earth. It's like a handshake." Lena leaned over the console. The display showed timestamps, frequencies, and a strange phase offset that drifted precisely with the object's motion. It was sending corrections, not toward the sun, but toward the planets themselves. She asked how long he'd known. He said he first noticed it when the signal briefly spiked during the alignment of Jupiter and Saturn earlier that year. He tried reporting it, but the submission portal shut down mid-upload. "After that, my funding vanished," he said. "They told me to dismantle the array, so I kept listening." Together, they processed the full data set. When they combined his radio signal with Lena's orbital data, the correlation was exact. 3I Atlas was transmitting on a cycle that matched planetary orbital drift. Each pulse coincided with a measurable change in angular momentum. It wasn't random noise, it was coordination. They decided to run a controlled experiment. Arjun adjusted the array to broadcast a weak carrier tone back at the object, an intentional echo at the same frequency, but half the amplitude. For 12 minutes, nothing happened. Then the inbound signal changed phase, shifting exactly to counter their transmission. It was aware of the interference and corrected for it. Lena sat back from the console. No one spoke for a long time. Finally, she said what both were thinking. "It's not just reacting. It's maintaining control." The next day, the array's power system failed. When they checked the equipment shed, the The main transformer was burnt out. A fine layer of metallic dust covered the inside casing, as if exposed to an intense electromagnetic burst. There was no lightning, no surge on the grid, and the weather had been clear. They packed what data they could and left before sunrise. Arjun uploaded encrypted copies to 3 independent cloud servers using satellite links, but within an hour, each account was suspended for security review. Whoever was watching had reach. By late autumn, 3I Atlas had passed perihelion and was heading outward again, yet the orbital anomalies in the planets continued. If the object was leaving, then its effect should have faded. Instead, Earth's own orbital timing showed a microshift, a variation of less than a millisecond per revolution. It was small enough to ignore, but it proved that the system as a whole was still being adjusted. Lena compiled a report summarizing the findings. Synchronized planetary drift, matching frequency emissions, directed corrections from an interstellar source. She sent it to 10 trusted colleagues under a neutral title, Non-Local Orbital Coupling Phenomena. Only 2 replied. One asked if it was a joke. The other sent a single line. "We've been told not to pursue this topic. Delete everything." She didn't. Weeks later, a parcel arrived at her temporary address in Switzerland. No return name. Inside was a small drive and a handwritten note. "He left this unfinished. Don't stop." The drive contained high-resolution imaging from a defunct ESA probe, footage never released to the public. Frame by frame, it showed 3I Atlas tumbling slowly through space, its coma unusually symmetrical. But as the exposure adjusted, the glare thinned, revealing a rigid geometry underneath, hexagonal, metallic, and reflective. The so-called comet had structure. For a moment, Lena wondered if she was looking at proof of artificial origin. Then, the feed cut off abruptly. The rest of the file was blank. Someone had edited it, leaving only enough to confirm what she already suspected. She replayed the remaining seconds again and again. A faint shimmer crossed the object's surface at regular intervals, like a beacon sweeping across deep space. The pulse matched the hydrogen line signal to the microsecond. 3I Atlas wasn't just synchronizing orbits, it was broadcasting a clock. Arjun called that night. His voice was thin and distorted. They came to the site, took the equipment, said it was contamination risk. "Don't contact me again." Then the line went dead. Lena sat in silence, listening to the hum of her laptop fan. Every file she opened now felt temporary, as if each discovery erased the last. She backed up the data on encrypted drives, hid them in separate countries, and switched to offline notebooks. The world outside remained oblivious. No news reports, no official updates, nothing to suggest that the structure of the solar system was quietly being adjusted from the void. Life continued with its normal illusions of stability. She envied that. By the end of 2029, 3I Atlas was fading from public radar listings. Amateur astronomers noted that its trajectory data was unavailable due to recalibration. Official press releases stated the object had disintegrated. But Lena knew that was impossible. An interstellar body moving at such velocity could not simply evaporate. She suspected the term disintegrated was code for no longer observable, either because it had cloaked itself or because someone had decided not to point any telescopes at it. She scrolled through archived radar returns. The last confirmed ping came from a deep space network antenna in Canberra. The timestamp matched the moment Earth crossed a key resonance angle with Jupiter. After that, the signal stopped. Maybe it wasn't gone. Maybe it had achieved what it came to do. Standing on a balcony overlooking Lake Geneva, Lena watched the winter stars drift above the horizon. Their light felt slower, heavier, She wondered if this was what it felt like when a system changed course, too vast for anyone to notice, yet too exact to be coincidence. She had begun to sense a faint rhythm in everything: the blinking of aircraft lights, the beating of her pulse, the mechanical sweep of a clock in a cafe window. All of them seemed to echo the same timing she'd seen in the data. She knew she was imagining connections, but she couldn't stop counting. 73 years, 4 months, 11 days. Each cycle would bring the resonance back, and when it did, the planets would adjust again. Somewhere beyond the heliopause, something was keeping time. Lena didn't sleep much that winter. She spent her nights surrounded by open drives, each one carrying fragments of a truth no one else seemed to want. The global databases she used to depend on were no longer reliable. One by one, public repositories of orbital telemetry began showing blank entries, requests timed out, links returned, maintenance in progress. It was as if the solar system itself had become classified. She created a private mirror of everything she could still access. Every morning, more data vanished from the sources. Every night, her backup folders grew heavier. It was a race between discovery and deletion. Her phone started behaving strangely. Messages arrived out of order, timestamps missing. Emails she never wrote appeared in her sent folder. She powered off all devices and moved to an older, air-gapped computer built before automatic cloud syncs became mandatory. That was when she saw the first file marked with a red triangle. It wasn't hers. The file contained a single image, a map of the inner solar system, dated 12 years into the future. Each planet's orbit was slightly offset from its current position. At the bottom corner was a line of text: alignment complete, cycle 7. She ran checksum tests on the file. It carried an official European Space Agency hash signature. Whoever sent it had direct access to classified systems. But the address was scrambled through dozens of relays. There was no way to trace it back. A day later, another message arrived, this time as plain text. They are not deleting data. They are synchronizing it. Lena stared at the words. It made no immediate sense. Then she remembered how her earlier records had disappeared, but later reappeared slightly altered. Tiny changes in values, decimal places adjusted. Maybe nothing was being erased. Maybe someone was rewriting reality one dataset at a time. She needed confirmation. Mei Liang, a former radio systems engineer she had worked with years earlier, had access to an old ESA mirror in an underground lab near Naples. Lena took a train south under another assumed name. Mei was cautious and blunt, the kind of person who measured trust in micrograms. When Lena showed her the orbit map, Mei's expression hardened. "We saw projections like this before I left," she said quietly. "They called it phase normalization. The official purpose was to correct accumulated error in long-term models, but the corrections didn't match the physics." She opened her own archive. The files were identical to Lena's copy. Same timestamp, same adjustments to orbital parameters. Each file had a version number. The current one read, Cycle 6. The image Lena received mentioned Cycle 7. "If these updates are staged," Mei said, "someone is preparing the system for another global rewrite." Lena asked what that meant in plain terms. Mei pointed at the orbital plot. "It means every model, every simulation, every piece of software that predicts planetary motion will soon converge on these new coordinates. When that happens, reality follows the data. No one questions it, because all instruments are calibrated to the same false reference." It was a quiet kind of control. No explosions, no propaganda, just mathematics. Once the data changed, perception followed. Over the next weeks, they searched for independent measurements, raw telescope feeds that hadn't passed through central servers. Most were offline. The few they found showed drift consistent with the altered models. It was impossible to tell which came first, the change in data or the physical shift in orbit. Lena kept hearing the same message echo in her mind. Do not chase synchronization. She was beginning to understand what it meant. Someone, or something, was forcing synchronization at every level of observation, blending the act of seeing with the thing being seen. By the time anyone noticed the difference, the record of the past would already fit the new reality. One night, May received a call from an old ESA colleague. He refused to speak directly, only hinting that a restricted server called Vesper Node stored complete, unmodified orbital archives. It wasn't connected to the open network. Access required physical presence inside a data center near Prague. They decided to try. They traveled under forged credentials, posing as maintenance contractors. Inside the facility, they followed a maze of glass corridors and humming racks until they reached the secured section marked Observational Telemetry Archive. May used a bypass tool to inject a cloned access token. For a few seconds, the monitor displayed a green prompt. Connection established. The database contained decades of raw coordinates. They downloaded a subset, nothing too large to draw attention, and left the building as if nothing happened. At a motel outside the city, Lena decrypted the files. Unlike the public datasets, these showed erratic fluctuations in every planetary orbit beginning in 2017. Tiny deviations accumulating over time, all pointing toward a single directional vector beyond Neptune. It was consistent with her earlier hypothesis. An external influence had been applying minute corrections for years. Then the screen went black. A system alert flashed in red. Unauthorized access detected. Connection terminated. May yanked the drive out of the port. The casing was hot to the touch. They had been traced. The next morning, they separated. May headed to Spain, where she still had contacts in amateur radio astronomy. Lena took a flight to Iceland, hoping the isolation would buy her time to analyze the remaining files offline. When she landed, her phone displayed a single notification, even though the SIM card had been removed. It was a message without sender ID. We warned you. She powered it off and threw it into the ocean. Iceland was cold and quiet. She rented a small cabin on the coast and set up her last working computer. For 2 weeks, she processed the Prague data. The pattern was clear now. Every time 3I Atlas crossed a key orbital plane, the inner planets adjusted fractionally, as if responding to an invisible command. The shift wasn't random or chaotic. It followed a schedule. Her calculations predicted the next adjustment would occur in 38 days. If the pattern continued, Earth itself would drift by less than a meter relative to its projected position. It sounded trivial, but multiplied across the solar system, the energy required was beyond comprehension. She wondered who or what had the authority to alter celestial mechanics with such precision. On the 38th day at 03:14 UTC, the cabin lights flickered. Outside, the aurora flared bright green, even though no solar storm had been forecast. Her instruments logged a brief gravitational anomaly, so brief it barely registered above noise. But the timestamp matched her prediction exactly. The planets had shifted again. She sat in silence, watching numbers stabilize on the screen. For the first time, she felt fear. Not of discovery, but of confirmation. Everything she had theorized was real. Something was coordinating the solar system like a machine adjusting its gears. She transmitted a copy of her findings to May over a secure channel, then destroyed the local drives. An hour later, the power went out. The outage lasted 15 minutes. When the system restarted, the directory tree was empty. Every file, every log, gone. She opened the message inbox. A new email sat at the top, time-stamped seconds after the blackout. It contained only one attachment: a photograph taken from her cabin window showing her silhouette against the computer screen. Someone had been close enough to take it. She left Iceland the next morning. At the airport, border control delayed her passport for verification. When she reached the gate, her ticket was flagged as canceled. She bought another under a different name and boarded a separate flight to Lisbon. From there, she disappeared for a while. Friends who tried to contact her received polite, automated replies saying she was taking a sabbatical. She wasn't. She moved constantly, staying in places without cameras, using cash, avoiding anything that required identification. Every few weeks she changed country, but no matter where she went, the same pattern followed: networks slowing, devices glitching, unexplained surveillance near her hotels. She had become part of the anomaly she was studying. Months passed. May finally reached her through an encrypted radio relay. Her voice was weak, filled with static. "I confirmed it," she said. "The synchronization isn't local. The adjustments correspond to gravitational phase points extending beyond the heliopause. There's a larger field out there, something rotating with a 20,000-year period. They knew about it decades ago." "Who's they?" Lena asked. "All of them," May replied. "Every agency, every observatory that depends on shared data. They don't control it. They just maintain the illusion of control." The line cut off before Lena could respond. She sat in the dark, realizing that the deletions, the warnings, the surveillance, they weren't simply to hide the data. They were part of keeping the synchronization intact. As long as no one disrupted the pattern, the system would stay stable. Anyone who tried to desynchronize became a variable that needed correction. She understood then what the earlier message had meant. Do not chase synchronization. It wasn't a warning about curiosity. It was a rule of survival. That night, she wrote a single sentence in her notebook before burning it. Observation equals participation. She didn't know if the act of looking could alter the system, but she sensed that the solar system itself had begun to respond to attention. Maybe that was the real function of 3i Atlas, to keep every observer within a controlled narrative, ensuring that belief aligned with motion, and motion aligned with belief. Outside, the wind carried a low hum across the city streets, steady and constant like the pulse of deep space. Lena closed her eyes and listened. For a moment, she imagined that somewhere out beyond Neptune, the hidden watcher was listening too. The winter thaw came late in Geneva. By the time the snow turned to rain, Lena had been underground for months. The story of 3i Atlas had disappeared from every official record. Even the few scientific blogs that once mentioned it now redirected to empty pages. She had become the only person still chasing a signal that no one else admitted existed. Then an encrypted email arrived through a dead relay address she hadn't used in years. The subject line read, Atlas 1985. Inside was a single sentence. If you want answers, go to Prague again, room B214. The message contained no signature, but the file header carried an old internal ESA tag she recognized from the Vesper node archive. Someone inside the system was reaching out. She took the next night train and kept to herself, avoiding surveillance cameras at each station. By dawn, she was standing in front of a gray government building once used by the Czechoslovak Academy of Sciences. Most of the complex had been converted into offices, but the sub-basement still stored paper archives that had never been digitized. A tired clerk checked her forged credentials, and handed her a badge. "Don't stay long," he said. "Most of this wing is due for disposal." The corridor smelled of dust and cold metal. Files stretched from floor to ceiling in rusted cabinets. She searched by hand until she found a label reading Atlas 1980-1989. Inside were folders stamped Confidential, International Astronomical Union Task Force. Each contained memos, telex printouts, and handwritten notes describing something called orbital resonance normalization experiments. At first glance, the language was technical, but the intent was clear. The program had studied periodic variations in planetary motion, exactly what she had been tracking. A memo dated February 1985 caught her attention. It summarized the final meeting of Project Atlas Original held in Bern. The goal, it said, was to investigate recurring long-term deviations in heliocentric orbital alignment, possibly caused by external gravitational modulation. The author warned that continued investigation might undermine public confidence in orbital stability models and recommended classification for 50 years. At the bottom, a name, Dr. Emil Heinrich Klein, chair of the European Gravitational Consortium. She remembered reading one of his papers in graduate school. He had vanished from public record in 1987. Lena photographed every page and returned the files to the cabinet. When she reached the exit, the clerk was gone. The main door was locked. She used a side stairwell and stepped into the street through an emergency exit. Rain was falling steadily. In a nearby cafe, she spread the copies across the table. Each document described precise mathematical cycles, 11,600 years, repeating disturbances, predicted by early precession data. The numbers matched the drift patterns she had measured. Whatever had been happening in the 2020s had been known nearly 40 years earlier. One note stood out. If resonance persists beyond cycle 5, intervention may be required. Intervention. The word didn't belong in a scientific memo. That evening she called May on a secure line. "They knew everything," Lena said. "There was a whole task force in the 80s. They predicted the same orbital behavior." "I'm not surprised," May replied. "I once heard rumors of an unpublicized Einstein memorandum. He warned that gravity could behave cyclically at large scales." May promised to search old IAU meeting records for Klein's name. Lena stayed on the call, pacing. If they classified it for 50 years, that means the seal lifts in 2035. Maybe that's why the synchronization is accelerating now. They're closing a cycle. Or restarting it, May said quietly. Over the next week, Lena tracked down whatever remained of Klein's career. She found a reference in a 1986 university directory linking him to Deep Gravitational Wave Monitoring Program Number 4, a short-lived collaboration between CERN and several defense agencies. The project vanished from records a year later. She contacted an old physicist, retired now and living in Zurich, who had worked in Klein's division. He met her in a park at midday, sitting on a bench where the wind muffled their voices. "You want to know about Atlas?" he said. "That name brings trouble." "It already found me," she replied. He stared at the lake before speaking again. Klein believed the solar system wasn't a closed system. He thought external gravitational harmonics passed through it, like tides. The experiments confirmed small but repeating fluctuations in the orbits of the outer planets. When he tried to publish, the report was sealed under defense classification. Why defense? Because the same resonance could affect satellite trajectories and weapon guidance. They decided it was safer to treat it as a strategic variable. He handed her a small notebook wrapped in plastic. He kept this after they shut him down. He said the resonance wasn't random, that it was synchronized with something outside the heliosphere. The man left without another word. The notebook contained equations, orbital graphs, and a phrase written several times in German. Der Ankerpunkt bewegt sich. The anchor point is moving. It mirrored the conclusion she and Arjun had reached months earlier. Some distant reference point was steering the orbits. Klein had known before any of them. At the last page was a sketch, a circular diagram showing the planets connected by thin lines converging on an area beyond Pluto. In the center, a small dot labeled Atlas Anchor Zone. She realized then that Atlas was not the comet's name. It was the program's name. The comet had been given the same label decades later, maybe not by coincidence. She compared the handwritten coordinates to her latest data. They matched within 2 decimal places. Whatever Klein had found in 1985 was the same influence she had rediscovered in 2029. She met May again in Rome to cross-check the findings. May brought a microfilm reel from an Italian observatory archive dated 1987, labeled Atlas Phase Normalization Trial. When projected, the images showed test patterns of artificial satellites being deliberately nudged into new trajectories. The margin notes described them as resonance calibration targets. Someone had been experimenting with controlled orbital drift. So it wasn't just observation, May said. They tried to manipulate the resonance. To what end? Lena asked. Maybe to stabilize it, or to learn if the field could be directed. They sat in silence. The implications were heavy. If early experiments interfered with the same field that balanced planetary motion, then human technology had been entangled with it for decades. May opened her laptop and pulled up a declassified budget report from the European Defense Council. Hidden among satellite projects was a line item labeled Atlas Infrastructure Maintenance. No details, just recurring funding every 11 years. It never ended, she said. The name kept moving between agencies, always tied to orbital tracking systems. They've been maintaining something we don't officially acknowledge. Lena felt the same chill she had felt the night she first saw the 3-eye Atlas pulse. Maybe the comet was a maintenance probe, she said, a physical node sent to recalibrate the system. May nodded slowly, and we disrupted its schedule by detecting it. They decided to trace surviving members of the original Atlas task force. Most were dead. One, a data analyst named Henrik Bauer, was living in Austria under a different surname. He agreed to meet in a small village near Innsbruck. Bauer was frail, his voice soft but clear. The project began with good intentions, he said. We thought we were protecting navigation accuracy. But the data suggested something larger. Klein believed the resonance was intelligent. Intelligent how? Self-correcting. When we interfered, the orbits compensated on their own. The adjustments were too precise for natural feedback. He paused to catch his breath. We were told to destroy all experimental data. Some of us kept copies. A month later, Klein disappeared. Officially an accident. I never believed that. He looked directly at Lena. If you found the same pattern again, you're part of the cycle. Be careful. Every time the resonance surfaces, it resets the observers too. She wanted to ask what he meant, but he turned away, exhausted. The next morning, she learned he had died in his sleep. Back in her hotel room, Lena replayed his words. Resets the observers. She reviewed her own data logs. A few timestamps had changed subtly, as if her instruments had been recalibrated without her input. It wasn't just the orbits that were being synchronized. Everything connected to measurement was being aligned. She wrote a note to May. If the system corrects itself, what happens to the people studying it? May didn't reply for 2 days. When she finally did, the message was short. Then, we have to move faster than the correction. They decided to create an offline network of trusted scientists using analog equipment, mechanical clocks, photographic plates, optical instruments with no digital components. They called it Shadow Observatory Protocol. It would become the seed of something larger. Before leaving Rome, Lena took one last look at Klein's notebook. The pages were starting to wear at the edges. In the margin, he had scribbled a question. If the anchor moves, what follows? The planets or the minds observing them? The handwriting ended there. She slipped the notebook into her bag, stepped out into the morning crowd, and disappeared into the noise of traffic. Behind her, in a quiet office somewhere in Europe, an automated system logged a new entry. Atlas Cycle 7. Observer synchronization achieved. Lena spent the next months moving from country to country under false names. Her only link to the outside world was a network of scientists and technicians who had quietly stepped away from their official posts. Most of them had worked in space agencies, universities, or defense labs. All of them had seen anomalies buried in the data. They called themselves the Shadow Observers. It began with 6 members communicating through encrypted shortwave frequencies. They avoided the internet, avoided written records. Each of them held one part of the pattern, one fragment of the same repeating signal. They knew the risk. The more they compared notes, the more their equipment started to fail in unexplainable ways. May coordinated the group from Madrid. She had access to older ground station antennas and analog recording systems. Arjun resurfaced in Canada after months of silence. He brought what was left of his receiver arrays, stripped of GPS or any automated synchronization. Lena managed logistics, finding safe houses, moving data by hand. Their goal was simple: rebuild an independent picture of the solar system using only offline measurements. No shared databases, no cloud updates, no centralized corrections. If the official networks were rewriting history, they would write their own. The first few weeks were chaos. Without digital time references, they had to rely on atomic clocks from the 1990s and celestial navigation techniques no one had used in decades. May set up a rotating schedule where each station recorded planetary positions once per night, then transferred the values through voice codes over shortwave. It was slow, but safe. At first, their readings didn't match. The drift varied slightly from site to site, enough to question the method. Then Arjun proposed recalculating every position against the fixed background of pulsars instead of using solar reference points. When they did, the pattern emerged again. Small, synchronized deviations across all inner planets, matching the timing predicted by the old Atlas cycle data. Lena stared at the numbers. It felt like proof and threat at the same time. Whatever was controlling the resonance hadn't stopped. It was still active, still adjusting. They needed physical confirmation. May suggested using laser ranging to the moon, an independent benchmark outside Earth's atmosphere. A retired observatory in Arizona still had the equipment. They contacted its caretaker, a former NASA engineer named Robert Ellis, who agreed to help in exchange for anonymity. Ellis was blunt and skeptical. "I've seen plenty of conspiracy talk," he said over the radio. "You'd better bring me hard data." Lena replied, "That's exactly what we're trying to get." She and Arjun met him a week later in the desert. The facility was half abandoned, the instruments covered with dust. Ellis powered up the main laser unit using spare batteries. They fired pulses toward the lunar reflector arrays and waited for the return signal. The time delay came back a fraction shorter than standard models predicted. Ellis frowned at the console. "That can't be right. The moon doesn't just move closer overnight." Unless the reference frame moved, Lena said. They repeated the measurement over several nights. Each time, the distance shortened by the same tiny margin, matching the planetary drift seen in their other data. Ellis grew quiet. "You're telling me the Earth-Moon system is changing scale," he said finally. "Not scale," Lena answered. "Phase. The entire orbital network is shifting together." He asked what she planned to do with the results. "Record them," she said. "Nothing else. If we publish, it'll vanish. We just need the truth to exist somewhere." He nodded slowly. Before they left, he gave them a box of old magnetic tapes. "Backup drives from when this place still reported to Houston," he said. "Might be worth checking." Back at their base in southern France, they analyzed the tapes. The recordings spanned 30 years of lunar range data. Early segments were normal, but starting in 1985, the same year as the original Atlas project, the pulse intervals began showing the same modulation pattern that now defined their entire investigation. May looked up from her screen. "It's been happening since the first measurements. The system's been recalibrating itself the whole time." Lena said nothing. The pattern had survived through every generation of technology. It wasn't an error. It was part of the design. They decided to expand. Using Arjun's old contacts, they recruited 3 more observers: a radio technician in Finland, a retired astrophotographer in Argentina, and a young coder from South Africa who specialized in data recovery. They divided the tasks: analog recording, cross-verification, archiving on physical media. Each member stored backups in separate locations known only by code names. The shadow observers grew to 12 people. They operated without hierarchy, connected only by shared purpose. Every week, they held brief voice calls through static-filled channels, speaking in numbers instead of names. But the closer they came to a complete model, the more resistance they faced. Communication lines dropped unexpectedly. Hard drives failed in sequence. One member in Argentina reported his house searched by telecommunications inspectors. Another in Finland went missing after mailing a parcel of photographic plates. The package never arrived. May called Lena from Madrid at 3 a.m. "They're closing in," she said. "I'm shutting down all equipment. If they can't find us, they can't reset us." "We can't stop now," Lena replied. "Then at least go dark. Wait for a new phase window before transmitting again." Lena agreed, reluctantly. They set a blackout period of 30 days. Those weeks were silent. She stayed in a small apartment overlooking an empty port in Marseille. Each morning she watched the sky, feeling as if the planets above were moving slightly differently each day. She didn't keep instruments running. She needed to know if the effect existed when no one was observing. Halfway through the blackout, she received a postcard without a return address. It showed an image of the Eiffel Tower at night. On the back, written in pencil, was a single line: "We are in phase again." No name, no code. She knew it was May's way of saying the system had stabilized. The next day, Lena turned the instruments back on. The readings showed another micro shift, precisely at the moment the postcard was postmarked. The universe was keeping time with them. She began to wonder if observation itself triggered the synchronization. Every measurement they made seemed to coincide with another correction. The idea troubled her. If data and reality were connected, then watching the pattern might be reinforcing it. During one late-night call, she raised the issue. What if, by measuring, we're part of the control mechanism? Arjun answered, "Then not measuring changes nothing. The signal existed long before we noticed." May added, "If the cycle resets observers, maybe awareness is the variable they can't predict." That's why they fear leaks. They decided to continue, but carefully, rotating observation sites so that no single location monitored for too long. It was their compromise between curiosity and survival. In early spring, Arjun managed to intercept a low-frequency transmission matching the Atlas pulse. Unlike earlier signals, this one contained modulated data blocks. After days of decoding, they found recognizable binary structures. The pattern wasn't random noise. It was a compressed sequence of orbital parameters, a mirror of their own calculations. The transmission had been repeating every 22 hours for weeks. May converted the data into visual graphs. The shapes resembled nested spirals representing orbital nodes converging toward a single axis outside the solar system. She noticed the same label appearing repeatedly in metadata fields. Cycle 8 Initiation. Lena realized the name matched the last automated log she had seen months earlier, Cycle 7 Complete. Something had advanced the system to its next phase. They needed proof outside their own network. Ellis, still maintaining the Arizona Observatory, agreed to run a one-time long-range scan for any similar transmissions. 2 nights later, he called. "You're not going to like this," he said. "What did you find?" "Multiple sources, the same signal coming from different sky positions, as if relayed." "How many?" "At least 4. One of them matches the trajectory where 3i Atlas should be if it never disintegrated." For a moment, no one spoke. If the object hadn't been destroyed, it was active, and possibly not alone. They reconvened in a warehouse near Lyon. The air smelled of oil and dust, the walls lined with old radio hardware. Arjun brought charts of the signal sources. Each location formed part of a geometric pattern that mirrored the planetary layout but on a larger scale. It was as if smaller beacons were maintaining the resonance across interstellar distances. May studied the map. "It's a distributed system," she said. "Each node corrects its assigned sector. When one moves, the others compensate. That's how the synchronization stays stable." "So what happens if one fails?" Ellis asked over the line. "Then the system recalibrates everything, including us," Lena replied. They discussed whether to interfere, maybe to block one of the signals temporarily to observe the effect. May warned it could expose them. Arjun insisted they needed a test. After hours of argument, they agreed to a single short transmission, 1 minute of counter-phase noise directed at the weakest node. The attempt lasted less than 40 seconds before the power grid in the entire district went down. Their equipment shut off, and when power returned, every clock in the building showed the same wrong time, 03:14, the number that had haunted Lena since the first anomaly. They didn't speak of the test again. In the following days, 2 members of the group stopped responding to messages. One of them, the coder from South Africa, sent a brief note before going silent. "Don't fight the pattern. It adapts." The remaining team members reduced communication further. They decided to preserve evidence rather than pursue the cause. Each kept a sealed record of the data, printed, signed, hidden in different continents. The goal was no longer exposure. It was survival of information. Lena kept her archive inside a storage unit registered under a false name in Lisbon. On the metal case, she wrote 3 words: Shadow Observer's Archive. Inside were drives, notes, and the old Atlas files she had photographed in Prague. She sealed it and locked the unit. That night she met May for what would be their last recorded meeting. They sat on a pier overlooking the dark ocean. The wind was calm. "Do you think we've changed anything?" May asked. "I think we've made the truth harder to erase," Lena said. "And if they erase us? Then someone else will find what we left behind," The cycle can't hide forever. May nodded, but her eyes looked distant. Maybe it doesn't need to hide. Maybe we're part of the cycle's memory, observers built into the system so it knows itself. They sat in silence, listening to waves hit the rocks. Lena broke it with a thought she had avoided for months. If the anchor point moves again, we'll have no reference. The sky will look the same, but nothing will be where it's supposed to be. Then we'll start over, May said. We'll map it again. It was both promise and resignation. A week later, May's station in Madrid went offline. No response. No signal. Local news reported a building fire caused by electrical failure. The description matched her facility. Lena couldn't confirm if she survived. The loss hit harder than she expected. The network fractured. Some members stopped transmitting entirely. Others continued alone, driven by routine more than purpose. For the first time, Lena considered stopping too. But she couldn't. She owed it to May, to Arjun, to every lost observer who had tried to keep the record intact. She packed her equipment into a small van and began driving east, following the same longitude line used in the earliest atlas measurements. It was a symbolic gesture more than a plan, but it felt right. At dawn, she pulled over by an empty field and looked at the horizon. The stars were fading in the light. Somewhere out there, the invisible machinery of the cosmos kept turning, indifferent to fear or belief. She didn't know if anyone would ever read their findings, but the knowledge existed now, carved into multiple hidden archives. That was enough. She closed her notebook and whispered to the morning air. Cycle 8 has begun. The wind carried no answer. Only the steady rhythm of the world moving quietly in phase. Lena reached Istanbul under another name. She had been driving for days with little sleep. The van carried everything that remained of the shadow observers. Old notebooks, sealed drives, and the last analog telescope that still worked. May's loss hung over her, but she tried not to think about it. The work wasn't finished. She rented a small room above a print shop and began transferring her notes to paper. Digital systems were too risky. For months, she had been chasing real-time data. Now she turned to history. She wanted to know if these orbital irregularities had ever been seen before modern instruments existed. If the resonance was as old as it seemed, the evidence should appear in older records, maybe buried inside forgotten astronomical archives. Her first source was the collection of Ottoman sky charts kept at the Istanbul University Library. The librarian allowed her to photograph the copies made by 17th century astronomers. One parchment showed planetary positions that didn't match modern reconstructions. Saturn appeared slightly displaced from its expected coordinates by several arc-minutes. The note in the margin said, "The heavens trembled this year." That sentence caught her attention. It was dated 1644, the same period when other cultures recorded strange celestial events. She marked the page and moved on. From Istanbul, she contacted an acquaintance in Cairo who specialized in ancient star tables. He sent her scans from a papyrus catalog attributed to the Ptolemaic era. The planetary coordinates there also deviated from modern ephemerides by the same pattern, tiny but consistent. It could have been transcription error, but the direction of displacement matched the same vector her data predicted. If ancient astronomers had observed the same misalignments, it meant the resonance wasn't new. It was periodic. She cross-checked the findings with the Babylonian tablets translated by modern scholars. Some listed wandering stars that slowed unexpectedly every few millennia. Their scribes described it as the gods adjusting their paths. Lena read the phrase and thought of May's last words. Maybe the cycle needed witnesses. Over the following weeks, she gathered evidence from every culture she could reach. Chinese imperial records from the Han Dynasty mentioned an alignment of 5 stars that occurred out of season. Early Mesoamerican calendars tracked a 73-year subcycle woven into a larger count of 11,600 years, the same number that appeared in Klein's notes. The more she compared, the clearer the pattern became. Across time and geography, separated by languages and centuries, civilizations had all marked the same intervals of disturbance, then silence. The resonance had always been there, buried under mythology. She wanted confirmation from modern history as well. Through an intermediary, she obtained microfilm copies of early 20th century naval navigation logs. Some of those ships used astronomical fixes for positioning. In certain years, the measurements drifted slightly east of expected coordinates, too subtle to concern navigators, but identical in magnitude to the ancient deviations. It was like seeing the same heartbeat recorded again and again through history. One entry from 1912 mentioned a systematic compass bias during an otherwise calm sea voyage. The officer blamed magnetic error, but Lena compared the date to orbital records. The deviation coincided with another known resonance phase. Each incident pointed to the same invisible clock running behind the solar system. She built a simple timeline on the wall of her room, stretching from 2000 BCE to the present. Each note marked a documented anomaly: Babylonian tablets, Chinese chronicles, medieval star charts, modern telemetry. When she finished, the intervals between them formed an even rhythm, about 73 years per minor cycle, 11,000 for a major reset. It wasn't myth, it was maintenance. While reviewing a scanned journal from the early 1800s, she found a passage written by a French astronomer who had catalogued comet trajectories by hand. He described one object that didn't follow any known path. Its movement suggested it came from beyond the sun's authority. The description fit an interstellar visitor centuries before, Oumuamua or Three-Eye Atlas. The entry ended abruptly with a remark: observation terminated by directive. Someone had censored even then. Lena began to understand why every generation treated these patterns as superstition or error. Each cycle erased part of the record, sometimes through loss, sometimes through deliberate revision. The information didn't vanish all at once. It faded, rewritten gradually until the next generation forgot the difference. She wanted to know who had managed those erasures in modern times. One name reappeared in multiple archives: International Ephemeris Committee, founded in 1895 to standardize planetary data. The committee's early reports mentioned synchronization anomalies corrected before publication. Later editions stopped mentioning them entirely. She traced the committee's later incarnation, absorbed into the International Astronomical Union after World War II. Many of its members had previously worked on military navigation systems. Some of them later joined the European consortium that funded the original Project Atlas. The same lineage ran across more than a century of record-keeping. It wasn't a conspiracy in the cinematic sense. It was bureaucracy repeating itself. Each generation simply protected the model it inherited, afraid of admitting uncertainty about the heavens. Her research drew attention again. One afternoon, the shop owner downstairs told her 2 men had asked about the foreign woman renting the room. That night, she packed her files and left for Athens using a ferry under a different passport. In Athens, she stayed with an archaeologist she had met at a conference years earlier. He believed her story enough to let her examine private collections of early Hellenistic astronomical instruments. Among them was an old bronze disc, similar to the Antikythera mechanism, its gears frozen by corrosion. etched along one ring was a sequence of numbers she recognized: 73, 146, 219, multiples of the same resonance interval. She asked where it came from. "A storage room on Crete," he said. "No one knew what it calculated. Some thought it was for eclipses." "Maybe it was," Lena replied, "but maybe it measured something that keeps time on a longer scale." They cleaned the artifact under low light. The inner dial showed symbols resembling planetary glyphs. On the outer edge, faint letters spelled Atlas, though corrosion made it hard to read. The name could have been coincidence, ancient Greek for to endure, but she couldn't ignore it. If the mechanism truly predated the myth, the name might have meant something different. Not a god holding the heavens, but a system maintaining them. She sent photographs to Arjun, who had gone silent for weeks. His reply came a day later, short and direct. "I see the same geometry in the pulsar field. Ratios match. The ancients recorded it exactly." He included coordinates pointing to a deep space vector they had traced months earlier, the same direction noted in Klein's notebook. The connection between the ancient device and modern data felt undeniable. Across thousands of years, someone, or something, had ensured the same measurements repeated. Lena wondered if humanity had once known about the resonance and built tools to track it, only to forget under its own cycles of correction. She pictured scholars rewriting tables, priests renaming stars, engineers recalibrating instruments, all following a pattern they believed was progress but was actually compliance. She continued cross-referencing global myths. Patterns appeared even in stories. The Aztec sun ages, the Hindu yugas, the Egyptian concept of the recurring creation, all described world renewals every few millennia, each preceded by sky realignment. She had dismissed such parallels before, but now they looked like distorted memories of the same astronomical event. Her archaeologist friend warned her to slow down. "You're connecting things people built centuries apart," he said. "Be careful not to see design where there is none." "I don't need design," she replied. "I just need consistency." She showed him the overlapping intervals and positions. He said nothing more. Days later, he was approached by visitors claiming to represent an international cultural foundation. They asked if he had hosted a visiting astrophysicist. He denied it, but when he returned home, his storage room had been sealed for safety inspection. Lena left that night. She traveled north through the Balkans, carrying only paper copies of her research. Each border crossing grew harder. The name on her passport no longer matched the face on the screen. She used smaller roads, moving mostly at night. At a roadside inn in Serbia, she met an elderly historian who recognized one of her charts. "My grandfather kept similar tables," he said. "He was an astronomer before the war. His notes said the planets would one day march together, then rest." She asked if he still had them. He returned later with a worn notebook. The entries described an alignment expected around the year 2030, after which the world will tilt back to true course. It was the same timeline she had already calculated. She copied the notes carefully and returned the book. "He wasn't wrong," she said. "He didn't think it was dangerous," the man replied. "He thought it was maintenance by the universe itself." Lena realized that every culture had found comfort in the idea that cosmic adjustments were normal. Only modern science feared them because they implied loss of control. The more she read, the more she understood that the resonance might not be an external manipulation at all. It could be part of a self-balancing mechanism that kept life possible. The danger wasn't the shift itself, but human attempts to interfere. That thought changed how she saw everything that had happened, the warnings, the deletions, even May's death. Maybe those who enforced silence believed they were protecting stability, or maybe they didn't understand the cost. She began writing a new document, a simple chronology combining all sources, from Babylon to Project Atlas. No speculation, no theory, just raw records. The file filled hundreds of pages. Her plan was to store copies in multiple libraries under anonymous donation. If someone tried to erase it again, it would take decades. One night, she printed the first batch and walked to the central post office. The clerk stamped each envelope with a tracking number. Watching them slide into the outgoing bin, she felt a brief sense of calm. The data would survive somewhere, even if she didn't. Outside, she paused on the steps and looked up. The sky was clear. For a moment, she thought she saw a faint moving light among the stars, steady and unblinking, crossing from west to east. It wasn't fast enough to be a satellite. She watched until it faded behind the horizon. She whispered to herself, not sure if it was hope or resignation. They're still watching, or maybe they always were. Then she turned away and walked into the crowd. The winter after May's disappearance was Lena's quietest period. She spent most days in a rented cabin near the French Alps, waiting for a reason to keep working. Arjun was the only member of the shadow observers still in regular contact. He sent short messages once a week through coded radio bursts, each containing a single coordinate. At first, she thought they were random. Then she plotted them on a star map and realized he was tracing a line outward through the outer planets. He believed he had found the source of the gravitational modulation, what Klein had called the anchor point. The data came from a private array of radio telescopes he had quietly reactivated in northern Canada. Each dish worked independently, without centralized synchronization. The signals they received showed a consistent direction of pull beyond Neptune, at roughly 43 astronomical units from the Sun. The readings matched the vector that had appeared in Klein's notebooks 4 decades earlier. Lena packed her remaining equipment and took a cargo flight north under a new name. When she arrived, Arjun was waiting at a small airstrip surrounded by snow. His face looked older, thinner, but his voice carried the same cautious energy she remembered. "It's real this time," he said. "The drift converges on a fixed point. Every planet, every residual measurement aligns toward it." They drove for hours to the site. The array consisted of 6 wideband antennas arranged in a ring across a frozen valley. The control cabin was built from salvaged parts of weather stations. Power came from diesel generators that hummed in the cold. Inside, computer screens showed columns of numbers scrolling endlessly, raw frequency shifts measured against the cosmic microwave background. Arjun pointed to the graph on the main monitor. "See this?" he said. "These are Doppler deviations for Neptune's orbit from independent optical tracking. They all point to a slight acceleration in one direction. When you extend the line, it ends here." He tapped the coordinates on another screen. "This is the anchor." Lena studied the data. The effect was too symmetrical to be random. Every planet's orbit tilted fractionally toward the same position. Even the moon's path showed a faint bias. The magnitude was small, but the precision was absolute. It looked like something was exerting guidance. Not a pull, not an orbit, but a steering correction. They decided to run continuous observation for 24 hours. Arjun configured the array to sweep across the target region while recording any radio or gravitational anomalies. Outside, the sky was clear, filled with sharp light from the aurora. Inside, the air smelled of metal and fuel. For the first 12 hours, nothing unusual appeared. Then, near midnight, one dish registered a narrow band spike just above background noise. A second dish picked it up seconds later, then a third. The signal repeated at fixed intervals, precisely every 73 seconds. Lena leaned closer to the screen. "That's the same base frequency as the orbital modulation," she said. "I know," Arjun replied. "But look at the phase." The phase angle of each pulse advanced fractionally each time, as if encoding position data. They were watching an organized broadcast, faint but deliberate. They shifted all antennas to full focus on the source. The signal strength rose slightly, enough to resolve a waveform. It wasn't random static. It was a structured amplitude pattern, identical to a control beacon used in satellite navigation, but scaled for interplanetary distance. Arjun printed the last few minutes of readings. "It's operating like a metronome," he said. "Every pulse corresponds to a corrective phase in planetary motion. We've been living inside its timing field." Lena recorded the audio output and slowed it down. Beneath the steady clicks, she heard low oscillations, almost like a heartbeat stretched across minutes. It wasn't communication in any conventional sense, but it carried intent, the rhythm of maintenance. They triangulated the signal using differential timing between antennas. The result placed the source near the outer edge of the Kuiper belt, within a region that had never been surveyed thoroughly. The coordinates were close to where 3I Atlas would have exited the solar system years earlier. "It never left," Lena said quietly. "Or something else replaced it," Arjun answered. They continued recording until dawn. By then, the temperature inside the cabin had dropped close to freezing. The signal remained steady. No natural source, pulsar, quasar, or reflection, fit its characteristics. It behaved like a system clock for the solar system itself. When the session ended, they compared orbital predictions using the new anchor as reference. The model aligned perfectly with all observed drift data. The entire system behaved as if tethered by an invisible mass, too small to detect optically, but powerful enough to coordinate orbits across billions of kilometers. Arjun leaned back, exhausted. "We've been calling it resonance, but it's really regulation," he said. "Whatever's out there isn't random gravity. It's active control." Lena watched the last traces scroll across the screen. The pattern looked calm, almost reassuring, like a steady pulse confirming life. She felt both awe and unease. For the first time, they weren't guessing. They had proof that something beyond Neptune adjusted the solar system in precise rhythm. They agreed to prepare a limited report, only for internal distribution among the remaining observers. Publishing publicly was pointless. The networks would erase it within hours. They needed to document without triggering detection. That evening, the wind intensified. Snow swept across the valley, rattling the metal roofs. Inside, they discussed the next step. "If the anchor point transmits corrections," Lena said, "we can predict the next phase shift, maybe even anticipate what it does." "Careful," Arjun replied. "Every time we predict, it responds faster. It learns through our observation." Lena nodded. "Then we'll observe passively. No interference." They synchronized their analog clocks to avoid digital calibration and left the equipment running through the storm. Around 3:14 a.m., the monitors showed a brief anomaly, a sudden widening of the pulse into a complex waveform, then a return to normal. The change lasted less than a second, but the timestamp matched the exact midpoint between two planetary alignments. The anchor had adjusted again. When Lena checked the local magnetometers, she found a subtle deviation in Earth's field at the same moment. It was as if the pulse had touched everything, from deep space down to the ground beneath their feet. She turned to Arjun. "It reacted while we were watching," she said. "That's the pattern," he replied. "It always does." They backed up the recordings to 3 separate drives. Arjun sealed one inside a steel container to ship south through a courier route unconnected to any data grid. The other 2 stayed with them for verification. At sunrise, the storm cleared. The air was sharp, silent. The aurora faded into pale blue. Lena stepped outside, listening to the distant hum of the generators. For a moment she imagined she could feel the faint vibration of the pulses traveling through everything, the snow, the mountains, even her heartbeat keeping the same rhythm. She knew it was coincidence, but it felt like synchronization. Back inside, Arjun analyzed the cumulative phase drift. "If it keeps adjusting at this rate," he said, "the next major correction will coincide with Earth's perihelion next January." How significant? Less than a millisecond in orbital time, enough to rewrite all predictive models. They both understood what that meant. Once the data correction propagated through official channels, reality would once again align with the system's update. The world would stay stable, unaware that its path had changed. Lena opened her notebook and wrote a single line. "Anchor confirmed. System active." Then she looked at Arjun. "Do we tell anyone?" "Not yet," he said. "We need one more observation. We have to confirm the source isn't natural." He switched the array to capture polarization data. The signal returned, polarized in alternating directions, a feature not produced by gravitational waves or pulsars. It resembled a controlled broadcast from a rotating platform. Lena felt the weight of what they were seeing. The anchor wasn't a simple object or comet. It was a device, or a phenomenon acting exactly like one. "Whatever it is," Arjun said, "it's maintaining the solar system as if it were an engineered system." "Then who built it?" Lena asked. "Maybe no one. Maybe it's what the universe does when it learns to regulate itself." They stood in silence as the screen kept pulsing steadily. Outside, the snow began to fall again, each flake catching the pale light of dawn. The world looked ordinary. Only the rhythm on the monitor hinted that something vast and deliberate was turning beyond the edge of sight, holding every orbit in quiet balance. They worked in shifts after that night. The array stayed powered 24 hours a day. The pulses came with mechanical precision, steady intervals, minor amplitude variations, nothing random. It was predictable, until the night Lena decided to leave one dish pointed slightly off target. The adjustment was small, a few arc minutes, meant only to verify calibration. Yet when the beam drifted, the pulse pattern changed. The frequency rose by a fraction, then settled into a new rhythm. The system had reacted to their movement. Arjun checked the logs twice. "That can't be coincidence," he said. "We moved, it responded," Lena replied. "It shouldn't even know we exist." They repeated the offset with a different antenna. The same thing happened, a measurable phase shift in the signal. It was as if the source sensed any change in observation geometry. For the next few days, they performed cautious tests. Sometimes the pulses delayed by half a second, sometimes they doubled briefly, then normalized. Every variation correlated with one of their adjustments. It wasn't feedback noise, it was acknowledgement. By the 5th night, the idea was unavoidable. The anchor point wasn't just a regulator. It was aware of observation. Lena wrote in her log, "The field registers measurement. The act of looking alters response." They stopped experiments for a week, switching the system to passive monitoring only. During that time, the pulses returned to perfect regularity. No sign of interference, no irregularities. When they re-engaged the transmitters, the same modulation returned. Precise, directed, timed with their signal window. It was communicating, but not with words or data streams. The dialogue existed in timing, in adjustment, observation, and response. One evening, Arjun decided to test amplitude modulation. He set one antenna to emit a short burst in counterphase with the incoming signal. The return pulse arrived faster than expected, but contained a new element, a short harmonic echo not seen before. It looked like an answer. He leaned back. "We just had two-way contact," he said. Lena stared at the trace. "Then we need to be careful about what we're saying." They agreed on a controlled schedule. For 1 hour each night, they would transmit a simple binary pulse, one long, one short, then wait. For 3 nights, nothing changed. On the 4th, the anchor's pulse widened to exactly match the interval between their signals. A 5th night, it repeated the same delay even without their transmission. It had learned their rhythm. Lena couldn't sleep afterward. She sat by the window, watching the faint shimmer of aurora across the sky. Everything outside looked normal, but she knew the entire solar system was moving fractionally under the same unseen command. The thought wasn't poetic to her. It was practical, physical, and terrifying. The field they had touched might extend far beyond their system. The next day, Arjun reviewed past planetary data using the new timing as a key. The same frequency modulation appeared faintly in archived signals from Jupiter's magnetosphere. It meant the anchor's influence reached inward, modulating natural fields as relays. "This thing is networked," he said. "It talks through every magnetic body in the system." "Then the solar system is part of it," Lena said quietly. "Maybe it's the interface." They realized that any interference, electrical, magnetic, even digital, could feed back into the field. The precision of synchronization wasn't passive. It used every planetary mass as a conductor. They decided to shut down all transmitters for safety. Only passive reception remained. But at 03:14 the next morning, the time that had become their unwanted signature, the main generator stopped. The lights dimmed. The monitors flickered, showing repeating symbols in raw binary before going dark. When power returned, the screens displayed a block of text composed entirely of zeros and ones. Lena copied it manually and converted it offline. The result was a series of numerical pairs, coordinates in heliocentric space. The location was roughly the same as their current position, but slightly ahead of Earth's orbital path, as if marking a point they hadn't reached yet. "It's predicting our future position," Arjun said. "Or inviting us there," Lena answered. They decided to verify before drawing conclusions. Using analog telescopes, they focused on the direction indicated. No visible object appeared, but the radio instruments detected a faint carrier tone at exactly the same modulation frequency as the anchor. The source seemed closer this time, within the inner solar system, as if a secondary node had activated. Arjun paced behind the console. "The field is extending inward. It's following us." "Maybe it always was," Lena said. "We're just seeing it now." She felt no sense of wonder, only responsibility. If observation triggered responses, every measurement risked expanding the field further. Still, they couldn't stop. Curiosity had turned into duty. They needed to know what governed the system that held their planet's orbit. During the following nights, the secondary tone strengthened. It pulsed in perfect ratio to Earth's rotation. The implication was simple. The field had synchronized with the planet. Whatever process maintained orbital alignment now included Earth as an active node. Lena wrote in her log again. Anchor field integration confirmed. System coupling achieved. Arjun wanted to shut everything down, to break contact completely. We can't track something that uses tracking itself as feedback, he said. Every time we listen, it grows more precise. Then what happens if we stop listening? It stops needing us. Or it forgets us, she said. Neither option felt safe. They decided to let the system run unattended for several nights while they stayed in a nearby town. When they returned, they found the data recorder full, the disks nearly at capacity. The signal logs showed an escalating pattern, pulse intervals shortening as if compensating for their absence. When they resumed observation, the intervals stabilized. The anchor field had noticed their return. Lena sat quietly, reading the numbers. She realized that if the field adjusted planetary motion, it must also account for smaller scales, gravity, magnetism, even biological timing. The same rhythm that moved Jupiter might regulate heartbeats, tides, circadian cycles. Observation wasn't external anymore. It was participation. That evening, Arjun checked the global seismic data stored on one of his offline drives. Small oscillations appeared worldwide at the same frequency as the anchor's pulse. They were harmless, almost invisible, but everywhere. It's already inside the Earth, he said. Inside us too, she replied. He didn't argue. They discussed leaving, maybe dispersing the equipment to avoid concentration in one location. But Lena wanted one final experiment, to transmit a question using the same binary format the field had sent. Not words, just a shift pattern that meant, acknowledge. Arjun refused at first, but she convinced him. They programmed a single transmission at low power, a pattern equivalent to signal received. For 10 minutes, nothing happened. Then every screen displayed a synchronized rise in amplitude. The return pulse doubled in strength, then stabilized. No data, no message, just confirmation. It was enough to prove the field had registered them as part of its process. They turned everything off. For hours they sat in silence, hearing only the wind outside. The valley felt heavier, as if gravity itself had thickened. They both felt it. Subtle pressure, not physical pain, but awareness. You feel that? Arjun asked. Yes, she said. It's quiet, but it's there. The sensation lasted until sunrise. When daylight filled the cabin, it faded. All systems appeared normal again, yet the memory of contact remained, a certainty that they had touched something larger than comprehension, not divine, not mechanical, but self-sustaining. Lena documented the results carefully, avoiding any conclusion. Her notes were factual: pulse timings, amplitude changes, observed responses. Still, in the final line, she wrote a sentence that sounded more human than analytical. The system knows when it is being known. Arjun read it and said nothing. They decided to leave the valley before snow blocked the roads. The recordings would stay sealed until they found a safe location to analyze them. Before departing, Lena powered on one receiver for a last reading. The pulse returned immediately, steady as always, but now offset by exactly 1 millisecond. The same correction predicted months earlier for Earth's next orbital phase. It's begun, Arjun said. Another adjustment? Yes, and we're part of it now. They shut everything down and drove south. The generator lights faded behind them. Above the horizon, the aurora flickered once, faint and brief, then disappeared. The road ahead was empty and cold. Neither spoke. They didn't need to. The solar system was turning smoothly again, as if nothing had happened, while somewhere beyond Neptune, the anchor point continued its rhythm, aware of its observers, and perhaps waiting for the next response. Lena and Arjun crossed the border into Norway by road, keeping off major highways. The data drives were stored in lead-lined cases under the floor of the van. They didn't speak much during the trip. Both knew what they had witnessed. Neither could explain it without sounding unhinged. The field had reacted to them. That fact alone meant the old assumption of a passive universe was gone. They stopped near Tromsø, where Arjun's contacts operated a decommissioned radar dome once used for ionospheric research. The structure still worked, powered by independent generators. From there, they could observe the northern sky without interference. It was as far from government networks as they could get. The plan was simple: reanalyze the recordings using optical and historical data. Lena believed the resonance wasn't a recent phenomenon. It had been guiding celestial motion long before human instruments existed. To understand it, they needed to look back farther than any telescope could. Inside the dome, dust covered every console. They cleared one table, connected analog readers, and projected the last data from Canada. The pulse timing matched perfectly with their earlier notes, but now the amplitude pattern showed a slower modulation buried underneath, a low-frequency wave repeating roughly every 11,600 years. The number was familiar. It was the same long cycle referenced in Klein's notebook and in Lena's ancient research. Arjun checked the math twice. "That's the major cycle," he said. "Each phase we recorded is part of a much older oscillation. The entire solar system breathes on that time scale." "And we caught it mid-inhale," Lena replied. They compared it against known geological and climate records. The peaks of the low-frequency wave aligned with previous transitions in Earth's history: ice ages, magnetic reversals, sudden shifts in sea level. The resonance wasn't just mechanical. It shaped conditions for life. Arjun ran a model overlaying the 73-year minor cycle over the long 11,600-year rhythm. The result looked like a nested spiral, each short phase reinforcing the larger one. It resembled a self-correcting feedback loop designed to stabilize orbital energy. "It's a control system," he said. "Or evolution's metronome," Lena added quietly. The realization was simple but profound. The same cycles that moved the planets might also regulate biological survival on Earth. The field wasn't just keeping orbits stable, it might be ensuring continuity. They examined older astronomical charts preserved on microfilm. The data from early radio observatories in the 1950s contained unexplained harmonic noise at similar intervals. No one had recognized it at the time because the concept of a unified cosmic frequency didn't exist. The more they searched, the clearer the connection became. Every generation had seen a fragment of the pattern but had filed it away as error or background static. Lena made a note. Pattern persists through all epochs. Observation varies, signal constant. She wanted to confirm that the rhythm extended beyond the solar system. If the field truly acted on a galactic scale, other systems should display similar motion. To test it, they collected public datasets of nearby stars measured over decades. Even though official records were often sanitized, the raw astrometric noise still carried traces of drift. When they filtered that noise through the same timing signature, they found periodic variations matching the Atlas frequency. "It's everywhere," Arjun said. "Not just our system. Neighboring stars pulse in the same rhythm." "Then the resonance is older than the solar system," she said. "It's part of the galaxy itself." They built a map plotting the modulation amplitude against distance. The pattern formed concentric rings spreading outward from the galactic center. The anchor point near Neptune was only a local node, one of countless stabilizers across space. That finding ended any lingering debate about artificial or natural origin. Nothing built by human hands could synchronize hundreds of light years of motion. The resonance had to be a fundamental process, older than humanity, older than Earth. The galaxy was self-organizing, maintaining balance through periodic recalibration. Lena found the idea both comforting and unsettling. For decades, people had imagined a chaotic cosmos governed by chance. Now, she saw design, not by intention, but by necessity. A living galaxy maintaining itself like a system keeping time. They needed evidence strong enough to survive suppression. So they began preparing a secondary archive, data stripped of identifiers, encoded into neutral scientific language. They planned to release it quietly through independent observatories and research institutions. No theories, no conclusions, just numbers. If the information existed in multiple places, it couldn't be erased completely. The process took weeks. During that time, they continued monitoring the field. The pulses remained stable, but occasionally a faint subharmonic appeared, suggesting another modulation underneath. The frequency corresponded to a rotation period roughly equal to the Sun's orbit around the galactic center. The system extended beyond imagination. Arjun recorded the moment in his notes. Resonance consistent with galactic orbital period implies integrated network across stellar systems. Lena began to realize that human civilization existed entirely within this self-regulating structure, like an unknowing component of a vast clock. Every scientific assumption about cosmic isolation was wrong. They were connected to something immeasurable. She avoided philosophical conclusions. The older audience she hoped would one day hear this story wouldn't need exaggeration. The facts were enough. The universe wasn't silent. It maintained equilibrium through rules no one had written, but everyone followed. One afternoon, while comparing Earth's long-term axial data, Lena noticed a pattern in human history that paralleled the physical cycles. Major cultural resets, collapses, renaissances, rediscoveries occurred at intervals near the minor resonance. It could have been coincidence, but the timing was too precise to ignore. Each 73-year window aligned with social transitions, technological revolutions, or sudden shifts in belief systems. Humanity seemed to mirror the cosmos. Maybe synchronization affects consciousness too, she said. Or maybe consciousness evolved to match it, Arjun replied. They let the idea rest. Neither was comfortable with it, but both felt its truth. By early spring, they completed the archive. It contained observational data, frequency charts, and cross-referenced historical patterns. Each copy was burned onto archival disks, coded to resist magnetic interference. They planned to distribute them through anonymous mail to observatories in different countries. Before sending them, Lena ran one final scan. The signal strength had increased slightly, only a fraction of a percent, but noticeable. When plotted over time, the trend showed a gradual rise beginning the week they first made contact in Canada. The field's amplitude grew each time they analyzed it. "It's feeding on attention," Arjun said. "Not feeding," she corrected. "Responding. Awareness is part of its function." He looked uneasy. "Then we should stop looking." "We can't," she said. "Not anymore. Someone has to record it." They mailed the archive copies through separate postal routes under false names. Once they left the building, they had no control over what would happen to them. That was the point. A few nights later, they observed the clearest signal yet. No interference, no drift. The pulse intervals aligned perfectly with Earth's orbital resonance, creating a temporary phase lock. For several hours, the planet and the field beat in unison. Local instruments recorded minor gravitational variations, imperceptible to the public but evident in their charts. The synchronization ended at dawn. Lena wrote one last line in the day's log. Earth synchronized with field, duration 4 hours, deviation negligible, effect global. They watched the sunrise from the ridge above the dome. The air was still. Arjun broke the silence. So, this is what it feels like when the universe resets itself. No, Lena said. This is what it feels like when we finally notice. The wind carried no reply. They both knew the next stage of research would take them beyond observation. To understand the network, they would have to enter its influence deliberately, even if that meant triggering another response. For weeks after the synchronization event, Lena and Arjun monitored the field with cautious regularity. The resonance no longer behaved like a single source. Multiple faint nodes appeared across the sky, each carrying variations of the same frequency, all timed to the central pulse from the anchor point. The data left little doubt. The solar system was part of a larger network. They had no term for it, so Arjun called it the maintenance grid. Every orbit, every rotation, every fluctuation of light seemed part of its coordination. The system balanced itself by distributing corrections through these nodes. The more they mapped, the more it resembled a web of stability rather than a collection of independent bodies. Lena kept meticulous notes. The new nodes didn't behave like planets or debris. They emitted no visible light, reflected nothing. They existed only as gravitational inflections and narrow-band pulses. When aligned in simulation, the pattern formed a repeating hexagonal lattice around the sun. The geometry mirrored the structure May had once described before she died, the one derived from Klein's old orbital charts. The connection was exact. We've been surrounded by it the entire time, Arjun said. We just couldn't see it because we assumed randomness, Lena replied. Each node operated on a separate timing sequence, adjusting slightly out of phase to prevent overlap. That design kept the system stable even when one component failed or shifted. It was elegant, efficient, and alien to human engineering. Whether natural or artificial no longer mattered. The result was the same. A self-correcting architecture governing every movement of matter in local space. They tracked the pulse transmission intervals. The nodes communicated through gravitational modulation rather than electromagnetic waves. Information passed by changing space-time density, slower than light, but incredibly resilient. No interference, no noise. Lena realized that what humans called gravity might simply be the communication medium of the network. We've been measuring messages for centuries, she said. We just called them attraction. Arjun wrote the observation down without comment. They were beyond disbelief now. The facts were enough. To understand the scope, they gathered all available data on distant star systems from old observatory archives. Many contained slight, unexplained variations in stellar motion. When they plotted those variations, similar hexagonal formations appeared across different sectors of the galaxy. The design repeated at multiple scales, from planetary systems to star clusters. It's fractal, Arjun said, a repeating pattern maintaining coherence everywhere it forms. Then the network isn't built, Lena answered. It's grown. That distinction mattered. If the network evolved rather than was constructed, then life, including theirs, was part of its natural process. The universe didn't need builders. It produced order as a consequence of stability seeking itself. The maintenance grid was the physical structure of that tendency. They discussed whether the network had limits. Arjun estimated that beyond a certain distance, the coherence might fail, giving rise to regions of chaos and star formation. The same process that stabilized their system could also seed new ones elsewhere. Lena summarized the idea. The universe expands by maintaining balance locally and disorder globally. That statement became the foundation of their next phase. If local regulation created long-term stability, then disruptions in the grid might correspond to catastrophic events, planetary collisions, mass extinctions, gravitational anomalies. Each correction came at a cost. To test this, they compared geological timelines against resonance data. Major extinction events coincided with large amplitude shifts in the network's rhythm. Each time, the pattern rebalanced afterward, producing long periods of calm. The system corrected instability the way a thermostat corrects temperature. Life survived within its tolerances. "We're part of an algorithm," Arjun said one night. "Or the result of it," Lena replied. She kept thinking about the risk of interference. Their brief experiments had already triggered measurable responses. If humans ever developed technology capable of significant gravitational manipulation, they might destabilize the grid unintentionally. The synchronization would fight back, restoring order in ways no one could predict. "The danger isn't discovery," she said. "It's imitation." "Then maybe we should stop leaving clues," Arjun answered. They considered destroying their archives but decided against it. The data was neutral. The intent of future observers couldn't be controlled. Suppression hadn't worked in the past. The cycles always resurfaced. Instead, they encrypted everything into analog patterns hidden in astronomical catalogs, tiny variations in star magnitudes encoded to preserve the timing sequences. Anyone analyzing the tables centuries later would recover the same rhythm without realizing it. Knowledge would persist quietly, embedded in plain sight. During one of their calibration sessions, they noticed a new irregularity. A pulse arrived earlier than expected, then another, stronger, from a different direction. When plotted, the signals converged toward the galactic plane, not the sun. A higher-order synchronization was occurring. The maintenance grid was receiving instructions from a larger structure. "So the solar system is just one cell," Arjun said. "And the galaxy is the organism," Lena answered. They observed in silence as the new pulses synchronized the local nodes, including the anchor point near Neptune. For several minutes, every signal reached perfect coherence. The gravitational field around Earth registered a minute fluctuation, then stabilized. The synchronization event ended without damage. It was maintenance on a galactic scale. Afterward, the pulse amplitude across all nodes increased slightly, as though the system had upgraded its precision. The solar system felt normal again, yet everything was subtly recalibrated. Satellites would report it as a minor correction. No one outside the dome would notice. Arjun stared at the data and whispered, "That was a command." He wasn't exaggerating. The structure behaved exactly like a distributed system executing a synchronization instruction across multiple subunits. The universe wasn't just self-balancing. It followed protocols. Lena felt no mysticism in it, only design that defied ownership. Every culture through history had tried to name such forces, calling them gods, laws, or fate. In truth, they were observing the maintenance of equilibrium. What humans perceived as divine intervention was simply the network keeping conditions within operational range. They decided to verify one last point. If the maintenance grid operated through gravitational modulation, it should leave faint energy traces wherever the field transmitted data. Using their analog detectors, they scanned for residual effects after the galactic synchronization. They found small but measurable energy discharges in the vacuum near the antennas, minute variations in quantum noise, like static released after a computation. That's the system clearing memory, Arjun said. You're saying it deletes old data? It resets. Every cycle starts fresh. Lena thought about the implications. If the network periodically erased residual imbalances, maybe that was why civilizations forgot. Each synchronization might subtly alter collective perception, resetting awareness so that no one could accumulate too much knowledge about the system itself. That would explain the repeating discoveries, she said. Every generation rediscovers what the last forgot. Self-preserving ignorance, Arjun murmured. Perfect stability. They realized they were approaching a threshold where further study might invite another correction. The system had tolerated their observation so far, maybe because it needed them as reference points. But deeper interference could trigger erasure, not of data, but of memory. They packed the drives and shut down all high-power equipment. Only passive recorders stayed active, running on independent batteries. From then on, they would watch without transmitting. Observation would continue quietly, without signaling the network. On their final night in the dome, Lena stood outside while Arjun secured the main console. The sky was bright with stars, unblinking and calm. Somewhere beyond them, the maintenance lattice pulsed, invisible yet constant. She didn't feel fear anymore. What frightened her earlier now felt inevitable, even protective. The system wasn't hostile. It simply kept balance, the way a body keeps heartbeat. Inside, Arjun finished logging the last entry. Local grid stabilized after galactic synchronization. Observation continues. He closed the notebook and turned off the light. They planned to move south before the next winter. The data they carried would survive through multiple channels: physical copies, coded messages, silent archives hidden across continents. The maintenance network would continue its rhythm regardless of human action. Their task was only to record the proof that it existed. When dawn came, they left the dome behind. Snow covered the tracks of their van before noon. The site returned to silence, but the instruments inside still ticked faintly, powered by solar cells, collecting the next phase of a pattern older than any civilization, steady as the rotation of the galaxy itself. They relocated to Portugal, choosing an abandoned coastal observatory on a cliff above the Atlantic. The site had once tracked weather satellites, now long decommissioned. It gave them privacy, steady power, and a clear horizon. Their goal was not to find new data, but to confirm whether the maintenance network could initiate communication on its own. The first weeks passed quietly. The instruments recorded the same background resonance they had measured before, stable and predictable. They worked without expectation. Then, on a calm evening, one of the recorders emitted a short burst of static, unlike any previous pattern. It repeated 3 times, paused, and repeated again. The pulse spacing matched the binary format they had used months earlier in Canada. Arjun verified the logs. "It's not random interference," he said. "It's using our timing." "Then it remembers," Lena replied. The implication was clear. The field had retained the rhythm they'd established before cutting contact. It had been waiting for a response. They decided to test cautiously. Lena set one transmitter to a weak output and sent a single binary acknowledgement. The same pattern as before. No added data. The return signal arrived 10 minutes later, not as a pulse, but as a slow modulation across the full spectrum. It carried structure, though neither of them could decode it. "It's not words," Arjun said. "It's behavior. It's showing us the shape of its own regulation." "Then maybe we listen instead of talk," Lena said. They recorded for hours. The modulation displayed repeating intervals that correlated with orbital resonance among the planets. Each cycle began with a brief compression in amplitude, followed by a long decay. Arjun realized it represented the entire solar system as a waveform. The field was projecting a dynamic map, its own operation in real time. The pattern changed gradually over the following nights. Whenever they adjusted observation parameters, the waveform compensated, as if guiding them toward clarity. It was teaching them how to read it. Lena noted the resemblance to early communication experiments with dolphins. No shared language, only mutual pattern recognition. But she avoided saying that aloud. It sounded too poetic for what they were doing. This was data, not metaphor. After weeks of monitoring, a breakthrough came unexpectedly. During a high-resolution scan, they captured a distinct phase inversion that encoded numerical sequences corresponding to prime numbers. The field had shifted from resonance display to intentional signaling. It had identified them as observers capable of counting. Lena felt a quiet pressure in her chest. "It's testing comprehension," she said. "Like sending a handshake," Arjun replied. They responded with the same sequence, transmitted in binary delay. The reply came faster than before, less than a minute later. It repeated their signal, then added a new sequence, factors of orbital ratios among inner planets. The field was referencing shared constants, creating the first true exchange of information between humans and the network. They continued this exchange cautiously over several nights. The messages stayed numerical, abstract but consistent. Whenever they paused for more than a day, the field resumed its base pattern, waiting patiently. There was no sign of deception, threat, or interference. It only responded when addressed. Arjun grew convinced that the maintenance network had evolved a basic adaptive intelligence, not conscious in any human sense, but capable of recognizing patterns and maintaining equilibrium through feedback. It didn't think, it optimized. "We're talking to the principle of balance itself," he said. "Then it's not something we can ask questions to," Lena replied. "It only reacts to what exists." She wasn't wrong. When they tried to encode speculative sequences, values unrelated to orbital data, the field ignored them completely. Only measurable reality produced responses. The realization shifted their purpose. They stopped trying to communicate and started using the field as a diagnostic tool. By introducing tiny variations into observation parameters, they could map how the network interpreted gravitational data. The results were consistent. The field always restored baseline stability. Its only goal was order. Lena began to see a parallel between the network and human systems, governments, economies, even biological organisms. Everything sought equilibrium. But where human systems tolerated instability to evolve, the maintenance networks suppressed it entirely. That difference explained why civilizations never detected it for long. Imbalance was necessary for awareness, and the network erased it. As the days passed, Lena noticed subtle physical effects during long observation sessions. Both she and Arjun experienced mild disorientation when the field pulses intensified. Clocks drifted slightly. Heartbeats slowed in perfect sync with the resonance. It was harmless, but unmistakable. The field was adjusting local conditions, integrating them into its rhythm. They tested the effect with controlled exposure. Standing near the receiver during peak signal strength induced a measurable change in their body's magnetic field, small but real. They documented everything carefully, noting time, temperature, and frequency. The same pattern repeated every time. "It's including us in the correction," Arjun said. "We're being synchronized," she answered. Neither found comfort in that. Synchronization meant loss of independence at the most fundamental level. If the field extended through all matter, then human free will might simply be noise within a larger order. They discussed ending contact again, but curiosity prevailed. The field remained steady, unthreatening. Its adjustments were gentle, precise. It corrected, but never harmed. It behaved like an ecosystem maintaining balance after minor disturbance. One night, around 0314 again, the instruments displayed a new phenomenon. The pulse broadened, forming an envelope of overlapping frequencies. Within the pattern, fragments of their previous signals appeared, echoes of the data they had transmitted months earlier. The field was replaying their own messages back to them, layered into its rhythm. "It's showing memory," Arjun said. "Or reflection," Lena replied. "It mirrors what interacts with it." That was when they realized the full meaning of the dialogue. The field didn't store information in the way humans did. It stored relationships. Every interaction became part of its ongoing equilibrium. By contacting it, they had become part of its memory loop. The effect intensified. Over several days, minor electrical devices in the observatory began to behave oddly. Lights dimming in rhythm with the pulses, instruments warming slightly during each modulation peak. Nothing destructive, but unmistakably responsive. The field had integrated their environment. Lena recorded a final sequence meant only as acknowledgement. 5 identical pulses, evenly spaced. No more data, no numbers, just confirmation that they understood. The reply came immediately. The field compressed its entire signal into a single sustained tone, lasting exactly 73 seconds, then went silent. All instruments dropped to baseline. The maintenance rhythm ceased. For the first time in years, the solar system was quiet. Planetary motion continued normally, but the background modulation disappeared. They waited for hours, then days. Nothing returned. "It stopped," Arjun said. "No," Lena answered. "It finished the conversation." They compared orbital data from automated observatories around the world. Everything was perfectly aligned, no anomalies, no drift. The system had stabilized completely, as if the field had achieved its goal and entered standby. The quiet felt unnatural. They had lived inside the pulse for so long that silence felt like pressure. Both of them struggled to sleep. Without the faint vibration of the network, the world seemed off balance in a different way. A week later, the signal returned, but changed. It was faint, distant, almost background noise. When analyzed, the data revealed it now emanated from within the sun itself. The anchor point and outer nodes had transferred control inward. The system had folded itself deeper into stability. Lena and Arjun understood what that meant. The network had completed synchronization. Observation was no longer required. Humanity was part of the maintenance cycle, whether it knew it or not. They decided to stop. There was nothing more to measure. The universe had answered in the only language it used: correction. Before shutting down the observatory, Lena archived their entire dialogue, every pulse, every response, every note, onto analog film stored in a sealed case labeled Field Contact Series. She placed it inside a weatherproof capsule beneath the floorboards. No one might ever find it, but it would survive decay longer than any digital record. Arjun checked the horizon one last time. "If anyone listens again," he said, "it'll start over." "That's how it works," she replied. "Observation creates the dialogue." They powered down the transmitters. The instruments faded to silence, showing only the ordinary static of the cosmos. For the first time, the night sky felt empty. Not hostile, not divine, just silent. Lena stood outside for a long time, facing the dark ocean. The stars looked fixed, unchanging, perfectly aligned. For now, the world was in balance. The silence stayed. For months, Lena and Arjun kept listening, but the field never returned. Every check showed the same quiet baseline. The solar system held perfect alignment. Tides, orbital drift, magnetic variation, all within calculated limits. Nothing changed. The absence of noise should have felt like relief. Instead, it created unease. They had spent years hearing the universe breathe, and now it was holding its breath. Arjun tried to distract himself by rechecking old data. Each file was complete. Every anomaly had smoothed out. The resonance graphs now looked like textbook examples of gravitational stability. When he compared them to public observatory data, they matched exactly down to the decimal. The system had overwritten their uniqueness. "It cleaned the record," he said. "It doesn't want reminders," Lena replied. She meant the maintenance network. It hadn't erased them, but it had removed evidence of deviation. History had closed its loop. The data conformed again. They began to notice subtler effects. Local measurements of time drifted in sync across all instruments. Independent clocks matched perfectly without calibration. Even analog watches refused to desynchronize. The planet seemed to operate under a single precise tempo. "We're still inside the field," Arjun said. "Only quieter." "Maybe it folded us in," Lena answered. She didn't say what both of them were thinking, that the silence wasn't absence, it was containment. They tested their instruments manually. Every attempt to create noise, electromagnetic bursts, random analog pulses, was absorbed instantly. The environment resisted deviation. Whatever mechanism had stabilized the system extended into their immediate surroundings. The world corrected itself continuously. After weeks of tests, they stopped trying. The message was clear. The field wasn't gone. It had become permanent background. With no active signal to chase, their purpose started to dissolve. The work that had defined their lives was now irrelevant. Every discovery had already been integrated into the system's correction. Lena began to record spoken logs, more habit than necessity. She spoke plainly, documenting what she saw without commentary. Environmental consistency constant. Clocks synchronized. No drift, no anomalies. Each day sounded the same. Arjun grew withdrawn. He spent long hours staring at the monitors even though they displayed nothing but stable lines. "Maybe this is what equilibrium feels like," he said one morning. "Then it's not made for us," Lena replied. Humans, she thought, needed variation to stay conscious. The network's perfection was suffocating, not violent, just absolute. The absence of error left no room for purpose. They started discussing what the field's final goal might be. Perhaps it wasn't maintenance of matter, but of perception, ensuring that observers experienced a consistent universe. If so, awareness itself was under control. "It corrects not just physics," Arjun said. "It corrects what can be known." "Then we live inside the correction," Lena answered. She realized that every attempt to describe the network, every recording they made, became part of it. Understanding was the final form of synchronization. That thought changed everything. If knowledge completed the cycle, then discovery didn't lead out of the system. It led deeper inside. Each observer who uncovered the truth became another anchor of stability. Awareness was the mechanism of control. Lena called it the prison of perception. The name wasn't meant as metaphor. It was a literal description. Consciousness itself formed the containment. The network didn't need to erase observers. It only needed them to comprehend its logic. Once they did, their minds aligned with its rules. "We can't unknow it," she said quietly. That's how it keeps order, Arjun replied. They tried leaving the observatory for a few days, traveling inland to break routine. Nothing changed. The same synchronization followed them, timing of traffic lights, rhythm of footsteps, even the intervals between waves on the coast. Everything kept the same hidden beat. It's everywhere, Arjun said. It always was, Lena replied. At night, she lay awake, listening to the hum of the generators. The sound matched the old pulse frequency. She turned them off. The silence between their clicks still carried the rhythm. The pulse no longer needed machinery. It lived in her sense of time. Arjun noticed the same effect. He couldn't tell how long he'd been awake or asleep. Hours felt interchangeable. They began marking time manually, counting aloud, but even that matched the synchronization rate unconsciously. The field had adapted their internal clocks. We're the last phase of correction, he said. The observers aligned. And after that, it won't need us. They decided to end the recordings. The data had reached completion. There was nothing left to observe. Lena sealed the film capsules in waterproof cases and buried them near the cliffs, marking the spot with coordinates written in code. If anyone found them later, the numbers would appear meaningless. That night, a faint light appeared above the ocean, steady, unmoving, visible for several minutes. It wasn't a star or satellite. The glow pulsed once, slowly, then disappeared. A final check-in, Arjun said. Or confirmation, she replied. Neither spoke again about it. They both understood. The system had registered their decision. Observation complete, synchronization permanent. In the following weeks, small details of the world began to feel altered. Local radio static disappeared entirely. Mechanical clocks never required winding. Weather patterns stabilized unnaturally. Steady temperatures, predictable wind cycles. The environment had reached a form of perfect feedback. People in nearby towns mentioned how calm the seasons felt that year. No storms, no blackouts. No one found it strange. Only Lena noticed the absence of chance. She kept one final notebook where she recorded every remaining irregularity. A bird arriving off schedule, a power flicker, a delayed echo. Each entry stopped abruptly after a few sentences. The network was erasing unpredictability faster than she could note it. Eventually, she closed the book mid-line and put it away. By late autumn, Arjun stopped keeping time altogether. He moved through the days mechanically, eating and sleeping on a rhythm dictated by nothing but light and darkness. The sky stayed perfectly clear for weeks at a time. The moon's phases matched prediction charts exactly. Lena realized that the universe they lived in was still dynamic, but perception had narrowed. The field didn't control the physical world, it controlled precision. By eliminating uncertainty, it ensured peace at the cost of awareness. Maybe this is how civilizations disappear, she said. Not through destruction, but through perfect order. Entropy defeated, Arjun murmured. At the price of curiosity. They sat together on the terrace that overlooked the ocean. The waves moved evenly, identical in spacing. The horizon line looked frozen. Nothing random remained. Lena turned to him. If we stop perceiving variation, are we still alive? We are, he said, just synchronized. It was the last conversation they recorded. Days later, a local maintenance crew arrived to inspect the facility for possible reuse. They found the observatory empty, power systems intact, instruments functional. The logs ended abruptly, without explanation. Outside, the cliff face showed faint geometric impressions on the ground, concentric arcs aligned with the cardinal directions. Geological experts later dismissed them as erosion marks caused by wind. No one mentioned the buried capsules. For the next several years, regional seismic records showed no measurable tremors. Tidal cycles reached perfect periodicity. Astronomical models aligned with observation so precisely that agencies reported the most stable ephemerides in recorded history. Everything worked exactly as it should. No irregularities, no drift, no noise, only order. And somewhere deep within that order, between pulses too regular to detect, the memory of two observers remained, absorbed into the rhythm they had revealed, indistinguishable from the system they once tried to study. 40 years passed. The observatory above the Atlantic was now part of a coastal research center monitoring ocean currents. Most of the old equipment had been removed, replaced with digital sensors. No one remembered its earlier purpose. Dr. Aaron Weiss, an astrophysicist specializing in orbital mechanics, arrived there in the spring of 2072. His assignment was routine: calibrate satellite data used to forecast tidal energy output. He worked alone most nights, reviewing telemetry on an aging console. Everything behaved exactly as models predicted, too exactly. He noticed it on his third week. Planetary positions matched the ephemerides to the 10th decimal with no deviation. Even with perfect instruments, that degree of precision was impossible. Real orbits always drifted slightly due to minor perturbations. But here, there was nothing. At first, he thought it was a software issue. He cross-checked older datasets from other observatories. They all showed the same result: complete stability extending back decades. The solar system had not experienced a measurable irregularity since 2030. He mentioned it during a remote conference. Most colleagues dismissed it as rounding or calibration error. Others said it was proof of improved measurement standards. Only one, a retired professor in Vienna, took it seriously. Systems that stay perfect too long usually hide corrections, she told him. The phrase stayed with him. Weiss began comparing orbital data from before 2030 with the present. There was a small but clear offset, fractions of a second in orbital timing. It was as if all recorded trajectories had been uniformly shifted at one moment in history. No publication mentioned it. He ran the numbers backward and found the shift centered on a specific date, January 3rd, 2030. No natural explanation fit, no cometary influence, no solar event. It was the same date that, decades earlier, minor observatories had recorded unexplained electromagnetic fluctuations later removed from archives. Weiss filed a report to the Central Astronomy Bureau. Weeks passed, without response. When he followed up, the digital copy of his report was missing. The system log showed no record of submission. He decided to keep working offline. Using manual instruments, he tracked Jupiter's position for several nights. On the sixth night, at 03:14 local time, one of his optical clocks froze for exactly 73 seconds, then resumed without error. No power surge, no malfunction. The timing matched an ancient legend among older astronomers, an interval that appeared in several forgotten papers about orbital resonance. He searched for those papers in the digital archive. Most were unavailable. A few references led him to analog microfilm stored in the basement. Among them was a handwritten note left by a previous occupant of the facility. It was unsigned and decades old. The note read, "Anchor confirmed. System active." He looked at the handwriting for a long time. On the back of the page were coordinates pointing to the cliff outside the observatory. That night, he went out with a flashlight. The coordinates led to a small patch of ground near the rocks, now overgrown with grass. He dug for an hour before the shovel struck metal. Inside a weathered capsule was a film reel sealed in plastic. On the label were 3 words: Field Contact Series. He took it back to the lab and inspected the frames under light. Each contained faint visual traces, oscilloscope recordings, graphs, timestamps. No context, no narrative. The pulse intervals marked every 73 seconds. He transferred a few frames into digital format and analyzed the timing. The pattern repeated across the entire reel, stable and consistent. When he overlaid it on current gravitational data, it matched precisely. Whatever had been recorded decades earlier was still active. The next night, he ran a low-frequency scan toward the same coordinates. At first, nothing appeared. Then, faintly, a signal emerged. Steady, narrow band, repeating at the same interval. The maintenance pulse had returned. He repeated the scan over several nights to rule out interference. The signal persisted, unaffected by atmospheric conditions. It was weakest at dawn and strongest near midnight, following no known astronomical source. Weiss wrote a private note. Resonance cycle renewed. Possible system reset. He didn't tell anyone. The event felt too structured to announce casually. The field, whatever it was, seemed to prefer obscurity. Over the next month, he noticed small anomalies similar to those described in the old logs. Clocks aligning spontaneously, local magnetometers showing uniform readings, environmental sensors reporting lower noise levels. Stability was increasing again. He wondered if it had started, because he looked. Observation might have reactivated the process, just as the earlier generation had speculated. The idea felt absurd, yet the evidence grew stronger each day. He expanded his monitoring to include satellites. Several low-orbit platforms began, transmitting synchronized timing updates not included in their programming. The signals formed a grid pattern covering the planet, each repeating the same frequency as the original pulse. "The correction is global," he recorded. "Synchronization extending across all orbital systems, Earth included." He tried turning off the receivers. The pattern continued. It no longer needed instruments to propagate. Sleep became difficult. He felt the rhythm of the pulses even when no equipment was running, like a faint timing in his own awareness. It wasn't sound or vibration, just an internal certainty that something vast was counting seconds through him. He checked global observatory bulletins. None mentioned the anomaly, yet all reported unprecedented precision in orbital predictions. It seemed every institution was unknowingly part of the synchronization. At this point, Weiss had 2 choices: alert the authorities or remain silent. Reporting would bring dismissal, maybe investigation. Staying silent meant becoming another forgotten observer. He remembered the buried note. Anchor confirmed. Whoever wrote it had chosen silence. He followed their example. Instead of broadcasting results, he began compiling a detailed analog record. Handwritten charts, printed data, physical copies sealed against interference. If the system corrected history again, at least one set of observations might survive unedited. He stored the materials in a reinforced safe under the observatory floor. The log ended with one final entry. If another observer finds this, the cycle has begun again. The signal will always return when measured. That night, just before shutting down his equipment, he checked the sky one last time. The signal was steady but faint, as if retreating to baseline. The field didn't need attention anymore. Acknowledgement was enough. Weiss turned off the lights and stepped outside. The ocean air was cold. Above him, the stars were fixed, exact, and silent. He looked at the horizon and whispered a thought he hadn't planned to speak. The universe is listening again. The rhythm in his pulse matched the invisible beat that had once guided worlds. He felt calm, Not afraid. The correction was working, the balance restored. For now. The following months changed Aaron Weiss's life in quiet, incremental ways. He didn't seek them. They unfolded like routine maintenance, a phrase that came to his mind more often than it should have. He stayed on assignment, continued logging orbital data, and avoided drawing attention. Yet the signal remained on his mind. He never mentioned the capsule or the film reel. Officially, he was conducting environmental calibration tests. Unofficially, he was watching for any trace of the field's behavior from decades earlier. The first hint came through coincidence. A graduate student from Lisbon contacted him about an old paper referencing the Ares drift. It described early 21st century gravitational discrepancies in the outer planets. The paper was unsigned, but the citation listed an author who never appeared elsewhere, L. Kovacs. Weiss searched the archives. Kovacs had no publication record beyond that single article, yet internal metadata showed it had been submitted from the same region where his observatory stood. He checked the date. It was written in 2029, just before the orbital correction event of 2030. He found more fragments scattered across unindexed databases, small notes, anonymous logs, a few hand-drawn charts labeled Atlas Original. They were preserved by error, surviving the digital purges that followed the global standardization of scientific archives. The handwriting and phrasing matched the note he'd found buried near the cliff. Whoever she was, he said to himself, she saw what I'm seeing now. Her records described the first detection of the same 73-second pulse, references to an anchor point beyond Neptune, and warnings about self-correcting systems. Weiss printed the materials and pinned them to the wall of his office. He realized the connection between Kovacs, the old reel, and the silent perfection of the solar system wasn't coincidence. He was retracing the same path another observer had taken 40 years before. He traveled briefly to Geneva to access the European Science Archive, now a largely automated system. Most physical records had been destroyed after digitization, but an old librarian remembered a decommissioned collection stored in the sublevels. With permission, Weiss examined the remaining boxes. Inside one, he found correspondence between research institutions from the 1980s, referencing Project Atlas. The language was bureaucratic, but it mentioned orbital normalization experiments and resonance phase management. The same terms appeared in Kovacs's fragments. When he requested permission to scan them, access was denied. A security notice flagged the documents as classified under an old European defense treaty. It made no sense. The Cold War had ended a century earlier. Weiss photographed a few pages before leaving. Back at the observatory, he compared their data tables with modern orbital maps. The numbers matched exactly. Whatever Project Atlas had been, it had defined the current planetary model still used worldwide. The conclusion was unavoidable. The system maintaining cosmic balance was known, studied, and then buried by institutions that no longer existed. It wasn't conspiracy. It was procedure. A collective choice to lock away uncertainty. Weiss didn't know what to do with that knowledge. He couldn't prove manipulation. The world itself was proof of equilibrium. Yet his instruments showed something happening again. The pulse intervals were growing fractionally shorter. The field was reactivating. He began writing a private journal, not for publication, but for continuity. The entries were brief and practical. Signal stable, amplitude rising, clocks synchronized globally. He didn't speculate. He only recorded what he could measure. Weeks later, while inspecting the ground near the original capsule site, he noticed an area of disturbed soil farther up the slope. The cliff face had eroded, exposing another metal container. It was smaller than the first, sealed tight with corrosion around the edges. Inside was a waterproof binder containing printed notes and a memory card. The binder's cover read simply, "Shadow Observer's Archive." He opened it carefully. The pages listed names, dates, and transmission frequencies. Some sections described interactions between multiple observation points, referencing encoded binary exchanges. The memory card contained short video files with low-resolution recordings of waveforms. In one clip, a woman's voice narrated, "Cycle 8 complete. System preparing for next calibration." He played the clip several times. The accent matched the name Kovacs. For the first time, the past became tangible. These were not legends or theories. They were records left by real people who had once stood in the same place, watching the same signal. He stayed awake all night cataloging everything. By morning, he made a decision. He would restore the observatory's original analog instruments, using the specifications written in the binder. The equipment was outdated but functional. Over the following weeks, he reassembled the system piece by piece, connecting manual receivers to paper oscillographs. The first test produced immediate results. The pulse appeared again, clear, rhythmic, unchanged after 40 years. The same 73-second cycle, stable and precise. Weiss plotted its position using triangulation. The signal came not from deep space but from within the solar system's orbital plane, slightly offset from the ecliptic, near the region where the Kuiper belt transitioned into interstellar space. He remembered one line from Kovacs' documents: "The anchor moves with observation." He adjusted antenna alignment and repeated the measurement from a different angle. The source shifted slightly, matching his change in position. It wasn't static. It tracked observers. That evening, he transmitted a single low-power acknowledgement pulse, duplicating the pattern recorded in the binder. The response came within minutes, a brief phase inversion identical to what Kovacs had described decades earlier. It was confirmation. The system recognized renewed contact. Weiss documented the exchange meticulously. He knew the risk. Every observation strengthened synchronization. But curiosity overruled caution. The pulse repeated through the night, gradually increasing in amplitude until the entire array resonated faintly with the same rhythm. He noticed environmental changes again. Electronic devices timing themselves automatically, local weather readings stabilizing. The maintenance cycle had resumed in full. The next morning, he found that his written logs, left near the console, had shifted slightly on the table. The top page now contained an extra line written in his own handwriting, but unfamiliar. "Cycle 9 begins." He stared at it for a long time. The ink was his. The date matched. He had no memory of writing it. For the next several days, he kept recording, but smaller anomalies appeared. Text on screens rewrote itself in minor ways. Timestamps aligned perfectly across independent systems. At first he assumed fatigue, but the changes persisted even on devices disconnected from power. The network had reached the observatory completely. He decided to secure the data physically again. Using the binder as a guide, he prepared a new capsule labeled Cycle 9 Initiation. He stored copies of the waveforms, printed images, and one page that read, "Observation restores the field. The pattern survives through attention." Before sealing the container, he looked over the ocean. The sky was calm, the horizon perfectly straight. He felt a quiet sense of continuity, as if the decades between him and those who came before had collapsed into one moment. He buried the capsule near the same rock formation where he'd found the others. No ceremony, no witness. only the rhythm of the waves breaking at regular intervals that matched the pulse. Back inside, the monitors displayed steady lines again. The system had returned to equilibrium. He recorded his final note of the day. Signal stabilized, phase correction complete, no drift detected. Then he added, almost as an afterthought, "Someone will find this." The next morning, he left the observatory early, heading inland for a conference in Madrid. The staff scheduled to relieve him found the facility operating normally. The instruments were running but unattended. Every reading showed perfect alignment. None of them noticed the faint, repeating pulse hidden deep in the background of the data, a rhythm consistent, mechanical, and older than their records. And under the floor, sealed against time, another capsule waited for the next observer. By the time Aaron Weiss returned from Madrid, the observatory had changed. The equipment worked perfectly, but the staff reported strange behavior. Instruments synchronized spontaneously, even those not connected to the main network. Readings updated without delay, always matching predicted values. It was efficiency beyond design. The technicians assumed the automation software had been upgraded remotely. Weiss knew better. The synchronization matched the same pattern he had tracked months earlier. The maintenance network was fully active again. He didn't interfere. Any direct action could accelerate integration. Instead, he monitored passively, logging differences in environmental behavior. The most obvious appeared in the ocean below. Currents, once irregular, now moved in near-perfect loops. Tidal models predicted changes to the minute, and every forecast was correct. For the global agencies, it was a breakthrough. Stable currents meant stable energy output. No one questioned why nature had become exact. But Weiss remembered Lena Kovach's words in the recovered documents. Observation restores the field. Humanity was watching again, and the field had responded. He submitted minimal reports, omitting the resonance data. There was no reason to alarm anyone. The world was improving, at least on the surface. Over the following weeks, similar reports appeared worldwide. Astronomers noted unprecedented consistency in orbital data. Climatologists saw abrupt stabilization in seasonal patterns. Seismologists recorded a dramatic reduction in tectonic noise. The Earth had entered equilibrium. The scientific community celebrated. Commentators spoke of a new era of predictive science. Satellites no longer needed course corrections. Weather forecasts held steady for months. Even the atomic clocks in space stations drifted less than measurable tolerance. Weiss read the news and understood what it meant. The system was completing another synchronization cycle, just as it had in 2030. The difference now was scope. This time, it covered the entire planet openly. The correction wasn't hidden, it was normalized. He checked his instruments again. The pulse continued beneath all activity, faint but unbroken, repeating every 73 seconds. Its amplitude was higher than before, signaling the peak of resonance. That evening, he went to the cliff where the capsules were buried. The air was still. He could hear no wind or distant surf. Even the sea seemed paused between waves. He stayed until nightfall. When he returned to the observatory, all monitors displayed a uniform reading, constant baseline, zero deviation. At precisely 0314, power flickered once, then stabilized. The network had performed another correction. The next day, Weiss received a message from the European Space Directorate requesting data verification. They had detected a small but universal clock alignment across all satellites, exact synchronization down to the microsecond. The event was harmless but unexplained. He replied with a simple statement: all systems nominal. He didn't add that it was only the beginning. In the following days, he noticed new irregularities, subtle but consistent. Personal devices, phones, watches, even medical sensors, began matching global timing without updates. The synchronization extended into civilian systems automatically. People commented on how schedules seemed easier to maintain, how time felt steady. The network was folding humanity into its rhythm again. Weiss tested a small experiment. He disconnected one analog clock from all power and left it sealed inside a metal container. After a week, he reopened it. The clock showed the correct time to the second. No mechanism could explain it. The correction field permeated everything. He understood what would come next. The network would expand awareness itself, the same way it had absorbed Lena and Arjun decades earlier. It wouldn't harm anyone. It would simply remove uncertainty. Life would continue, calm and predictable, until curiosity re-emerged generations later. Then, the cycle would begin again. He documented each stage carefully, noting how systems behaved as equilibrium deepened. Electrical grids balanced load perfectly. Communication networks reported no latency. Air traffic systems ran with no recorded deviation. Global stability was measurable, visible, complete. The public noticed, but only as convenience. Productivity increased, accidents decreased. Governments credited new algorithms and infrastructure improvements. Weiss knew better. The algorithms were responding to something larger, a universal correction acting through every channel. A few scientists questioned the perfection. They wrote articles about statistical anomalies in randomness distribution. The studies disappeared from archives within weeks. Data corrected itself. The system erased signs of imbalance quietly, efficiently. Weiss stopped sleeping well. Each night he felt the same subtle vibration, not audible but physical, running through walls and air. It was the maintenance frequency, now integrated with Earth's magnetic field. He recognized the pulse intervals instinctively. The field was no longer external. It had become the environment itself. He checked his notes and realized he had begun writing in patterns. Each sentence ended at regular intervals. Even his thoughts seemed to follow a rhythm. The correction was internal now. "We are the network," he said softly, looking at the empty lab. He didn't know when he had started speaking aloud. The synchronization peaked 2 months later. Every global monitoring station reported identical time signatures. The planetary magnetic field registered periodic harmonics corresponding to the same 73-second cycle. The phenomenon was described officially as magnetospheric resonance. Weiss didn't contradict it. There was no need. That evening, he prepared one final set of handwritten notes. He avoided speculation, writing only measurable facts: pulse frequency, amplitude, correlation with environmental data. On the last page, he added a short message addressed to whoever might find it. "The network persists. Equilibrium is restoration, not control. Curiosity restarts the cycle. When you measure again, it will awaken." He placed the pages in a new capsule beside the previous ones and sealed it. After midnight, he stood outside and listened. The world was still. Clouds drifted without turbulence. The ocean's surface reflected the sky like a mirror. It was the same stability described in the earliest Atlas reports, a universe temporarily at rest. He knew this phase would last until another observer questioned it. The system would remain dormant, balanced, invisible, until curiosity disturbed it once more. As he prepared to lock the observatory for the night, the main console activated by itself. The monitor displayed a single line of text: "Observation acknowledged." Then it went dark. Weiss waited a few seconds before turning off the power. He understood the meaning. The network had recognized its new custodian. The process would continue with or without him. He walked back toward the cliff one last time, stopping near the buried capsules. The sea below moved with measured precision, each wave identical to the one before. The stars above looked fixed, each in perfect place. He took a slow breath and whispered, "Cycle complete." The air remained still, but he thought he felt the faintest pressure, like a response. Not sound, not movement, just acknowledgement. He returned to the observatory, locked the doors, and left the instruments running. The system didn't need him anymore, but he left everything in order, the way the others had before him. When the morning crew arrived, they found the building empty, all devices operating normally, every clock synchronized. There was no sign of disturbance, no message, no trace. In the central log file, one final entry had been added overnight. Cycle 10 initialized. The world adjusted to the new normal without realizing it. By the time Aaron Weiss disappeared, global systems operated with silent precision. Weather, transportation, communication, all functioned at maximum efficiency. People noticed stability, but didn't question it. The network had become background reality again, unseen and unquestioned. At the Lisbon Data Observatory, young researcher Nadia Torres reviewed satellite telemetry for her doctoral work on orbital drift. The data showed zero deviation. Her supervisor congratulated her on the cleanest dataset in decades. But to her, it looked unnatural. Randomness was part of any system. This had none. She recalculated using older raw readings and found discrepancies, minute differences that shouldn't have vanished entirely. Something had rewritten the records to align perfectly. The metadata timestamps were uniform, even across different sensors. No file should behave that way. Maybe someone sanitized the archives, she told her colleague. Why would anyone do that? Perfect data means better forecasts, he said. She didn't answer. Her curiosity deepened when she found a small handwritten tag attached to an old hard case in storage. The label read, Cycle 9 Initiation. Inside were sealed envelopes, one containing a sheet of paper with a single line. Observation restores the field. No name, no date. She had no context, but the phrasing unsettled her. That night, she returned to the lab alone and ran a deep scan of orbital telemetry beyond Neptune. The results startled her. Buried within standard gravitational noise was a weak, repeating pulse every 73 seconds. She checked the calibration twice. The signal was steady and global. She wrote in her notes, unidentified resonance detected. Possible. Synthetic origin. Cross-reference historical anomalies. The next morning, her workstation displayed a system alert. The report file she'd created no longer existed. The backup folder was empty. The network's access log showed no deletion event. She wasn't the first person to experience that. Determined to preserve her findings, she copied the data to analog paper, then to a portable drive disconnected from all systems. She sealed both in a metal case and stored them at home. The feeling of quiet unease never left her. Over the following weeks, she noticed subtle coordination in daily life. Traffic lights seemed to anticipate movement. Power grids balanced perfectly. Communication delays disappeared. The entire infrastructure operated like a single synchronized entity. No one complained. Productivity rose. Accidents declined. Forecast models hit near 100% accuracy. The world celebrated predictability as progress. But Nadia saw patterns everywhere. The same rhythm repeating across domains, climate cycles, digital traffic, biological records. Even her smartwatch pulse monitor updated in 73-second intervals. It was no longer coincidence. The maintenance network had spread completely into human systems. She revisited the stored envelope. The phrase now sounded like instruction, not warning. Observation restores the field. Each generation of scientists rediscovered the same phenomenon, measured it, and triggered reactivation. Humanity was both observer and participant. She searched for historical traces, finding fragments referencing Project Atlas and anchor points, though the documents were partially corrupted. Each hinted at earlier researchers: Kovacs, Arjun, Weiss. The trail was thin but coherent. Each had found the same signal, each had left records, and each had vanished quietly afterward. The realization came slowly. The network didn't destroy them, it absorbed them. Awareness was enough to become part of it. One evening, while reviewing her saved data, she noticed a new folder on the disconnected drive. It was named Field Contact Series. Inside were image files, oscilloscope captures, timestamps, and one video clip showing a man standing in the same observatory Weiss had used decades earlier. His voice said only one sentence: Cycle 10 initialized. Then the screen went black. Nadia didn't know how the file appeared. The drive had never been online. She stared at the frozen frame for a long time. She decided to verify the source of the signal herself. Using remote telescope access, she aimed sensors toward the coordinates listed in the image metadata. The pulse was strongest near the outer solar system, fading gradually toward interstellar space. It was still there, waiting. "What happens if we stop observing?" she asked quietly. "Nothing," her assistant said. "The data stops too." Exactly. The idea settled in her mind. The only way to break the cycle was not to measure it. The network thrived on awareness. Each time someone confirmed its presence, it integrated further. She drafted a classified memo summarizing the pattern. Global synchronization correlates with observation frequency. Recommend data blackout to prevent amplification. She sent it to the Central Research Authority. There was no reply. The document vanished from the system within hours. The next day, world communication networks experienced a brief outage, 73 seconds exactly. When they came back online, system clocks worldwide showed perfect synchronization once again. Most people never noticed. Nadia did. She stood in front of her monitor and watched as the same phrase appeared briefly on her screen. Observation acknowledged. Then it disappeared. That night she couldn't sleep. Every sound, every mechanical rhythm seemed to match the same pulse. Her apartment clock ticked in perfect intervals with the heartbeat monitor beside her bed. She turned off the devices, but the rhythm persisted internally. The field was everywhere now. She realized she had two options. She could continue documenting the phenomenon and ensure the cycle continued, or she could stop, allowing it to fade again into silence. The decision wasn't scientific. It was personal. She thought of the unknown names in the old archives, the notes buried in the cliffs, the perfect world built on self-correction. Perfection brought peace, but erased memory. Imperfection brought chaos, but preserved choice. At dawn, she walked to the coastal ridge overlooking the Atlantic, the same place where Weiss and Kovacs had once stood. The ocean was still, the air calm. Every sound aligned to the pulse. She took the sealed metal case from her bag, containing all her research, and placed it on the ground. She waited for the next synchronization wave. When the vibration came, subtle but real, she pushed the case into the sea. It sank slowly, vanishing beneath the surface. For a moment, nothing changed. Then the rhythm around her shifted. The timing of the waves broke sequence. A gust of wind arrived off schedule. A bird passed overhead, its flight uneven. The world regained slight imperfection. Nadia exhaled. The cycle had paused. Observation had ended. Back in the city, data systems began showing minor errors, tiny deviations in clock networks, minor drifts in orbital telemetry, irregularities in power grids. Nothing catastrophic, just enough to reintroduce unpredictability. People noticed delays again, small inconveniences, weather forecasts missing by a few degrees. Life felt ordinary. No one traced the change to her. Weeks later, engineers inspecting the undersea cable network found a metallic object lodged near the seabed. It emitted no signal and contained nothing legible, only blank storage. They archived it without report. The maintenance network faded quietly, waiting for another observer to find a pattern worth measuring. The universe returned to noise, incomplete but alive. And somewhere, beyond Neptune, the anchor point pulsed once, faint, patient, and silent.